wonder who's watching these things on YouTube. Like, it seems like every time I refresh the page, it's counts one view on every video. Like, I'm sure a view is just like, checked it out real quick and then logged off. Obviously didn't watch all 8 hours through, but it's just a fun little tidbit, I guess, to watch the adventures of Bob. Bob, the guy who builds things. Anyways, we're here. We had a view of our triumphant cabin. We're gonna have to go back to the wall at some point. Right now, though, we're gonna put scrap in the scrap heap. Just start the day. I can't tell which is country. Is this the country? I guess it'll tell me what station it is. Yeah, country. Okay, there we go. Those are our daily working tunes. Just daytime work is country, nighttime work is, I don't know, listening to the lectures. We didn't finish that lecture on fucking cellular evolution being as part of the environment, I think. Being an energy transfer rather than, it's something separate. Like, a cell is just part of the environment, separated by a thin membrane. And if you look at organelles or even proteins, you see like little machines, right? Like turbines and stuff. And that's how they do things. It's mechanical instead of, there's this concept that a biological process is separate from a physical process or a mechanical process. And at the protein level, the molecular level, that's just not the case. They are just, moving around. It's these quirks in movement that give them their properties. I think that's what the talk is saying. Was saying, anyhow. Otherwise, daytime travel music at night, well, all types of travel music are just, the radio. I don't know if the sun's setting or it's just cloud cover, but, we're doing things. We're having a fun time. Again, server settings I changed for to way increase the what is it called? The amount of puppets that can spawn outside. I had it at 2 times. But now I set it to 5 times. If we can find more puppets just out in the wild, wandering about. Little puppet world. Anyways, we're going to take stock of what we have. We have, like, equal amounts of these two. What are we feeling? Well, it says American. Let's have American bar. Just quench our thirst. Continue work on the wall. No, let's not throw it away. Although, I don't know. Hold on, let me examine it. A big old Christmas gift. Oh wait, it's a component of the Christmas gift? I don't think that's right. Oh, you can use the Christmas gift to get beer. Okay. But otherwise, it's used for a can suppressor. Some explosive stuff. I don't think I want to blow puppets up quite, but I don't know. Let's see. All we need is a blast cap, really. And a blast cap you get from scrap gunpowder. So we could have a nice little explosive bolt. But nah. Wheat litter. Let's let that be someone else's problem. Garbage men need a job, right? And we're helping our fellow workers. We gotta sell all this aeroplane stuff, okay. I think a treasure run around the compound, and then heading to the outpost. Because I don't know when night's gonna fall, but it should be not that far away, let's say. That plate's not go in the car, I think. It's just cloud cover.
For the catch right then, it was Sunday. When mom came in morning when he tried to make me pay the rent, said I ain't got no money for you, cannot pay me away with these dancing shoes. I was kidding.
You know, I need to find way more bobby pins around the place so that I can, I don't know, train my lockpicking in police stations. I don't even build anything at this point, so why not go back to the global alliance? What's this one? Oh, I also think I changed the rarity and increased the rarity on cargo drops. Yeah, just cause. Back to that, 4 to 8 hour window. That can be smashed. Can only be used for the improvised mask. Okay. Why can't the improvised scope use it then?
Gladiatorial Combat Evolved. I'm your host, John Dick, and welcome to Scum Island. We've got some interesting events for you to check out. Try your hand at Deathmatch, Team Deathmatch, Capture the Flag, or Cargo Drop. Let's get some music on to set the mood.
Just wonder if it'll crash on the song again. Nah, it didn't crash. I think we gotta have to use this bad ammo. Waste not, want not, right? disappears into the bush. He's trying to lure me into an ambush, huh? Hey, an ambush. What an asshole. We'll see. Yeah, that caravan is not good. Hold on. I have 5 shots. Okay.
Wakes up, touch it gently, you are feeling completely calm. Hold it in your palm and help it grow just like it was born to be.
Alright, turning up the zombies was a good idea, because this is a very untenable situation. Finally some threat, and I need to urinate. Alright. They're actually dangerous. Anyways, at the shelter, let's do it. Though it's a good thing I know where I died. Need a better battle plan than shooting things, because that's very dangerous. Darn donkey. I blame the donkey. That was the revenge of the donkey. That's what we'll call it. It set me up. Yeah, this is the opposite of good, actually. Maybe I turned the puppet count too much, too high up. Alright, well, before I bleed out, my objective should be to just get back to my body. Hey, I got 2 experience points for running. Neat. I do like how dangerous this is, though. Maybe 5 times was a good call, because, geez, that swarm. Now I feel like they're a threat. I wonder if we just buy the immune boosters at the apothecary and just let that sort it out. If we just use it, we probably use absinthe to disinfect the place. Anyways, my fatal mistake was that I forgot that I had a pistol. That's the long and short of it. Is like switching your sidearm is faster than reloading, but I thought my sidearm was a giant fucking sledgehammer. You should be careful with your injuries. Fuck you, mate. Like, where are these people coming from? just can't wait until puppets get more dangerous. Then, like, they can actually climb stuff or fall through windows or whatnot, instead of just, being able to be herded like that. They could actually find their way up to you. Like, if you can get there, puppets can get there. Anyhow. Meant to do that.
How's it hanging? See ya. Welcome, welcome. Feel free to browse around.
I think we'll allow ourselves to buy a drill. A singular drill. No. Yeah, sure. Yeah, no. I don't know. Our money would better be spent on toolboxes, I believe.
So, what will it be?
Or maybe even gravel or cement. We'll check. We'll come back later. It's getting dark. We gotta be, I don't know, quicker. what we wanted to do. Come sell the airplane kits.
What's up? If you're trying to rob that thing registered. Kidding. Nobody cares.
Just because I can do this. Yeah. Super Kung Fu Man. Let's use Sledge. Why is he swinging like such a bitch? Whatever. It's like he's swinging it slow from... Oh, okay. I see. No, he is moving his hand down, and that's why he's just putting a lot of weight behind it instead of saving those for when they're off kilter. It's just like, I'm just going to open up with the heavy attacks. Anyways.
John Dick, welcome to yet another fierce bloodbath. The best way to gain daily gold is by registering. What are you waiting for, scrub? Sign up and rank up. Now, get out there and paint the town red with blood, you degenerates. Make your mama proud. my friend, look like somebody who could use a bit of action. You came to the right place. I'm your host, John Dick, and welcome to Scum Island. We've got some interesting events for you to check out. Try your hand at deathmatch, team deathmatch, capture the flag, or cargo drop. Let's play some tunes, shall we?
Of course I find an M9 magazine. After the day after I buy one. She just fucking trip and die. She jumped up here. She spawned in my cabin. Where the hell'd she come from? I think that's a puppet spawned in there by our fridge. I wonder if this bullet can go through glass. Apparently not, just fucking invincible. Bulletproof glass. What a well-equipped hangar. That bullet just shredded her insides. What the hell? Okay, well, you have fun with that. I'm gonna check on your friend. Because, that was, pretty rude. She can't pass through this little gap here. Poor girl. I was hoping she'd be the one with a camera lens. I just, I don't know, make things poetic. Oh, I guess it's this box that's tripping her up. She's like, this is an unpathable box. They can't handle small inclines. So maybe if there are not enough puppet wild spawns for the spawns that they want to spawn, like, you know, I have 500%, but, you know, the amount of wild spawners around me can't handle a 500% capacity, so it borrows from other classified spawners. That's my best guess, because, geez, these two indoor spawns are flagged, and, well, I guess maybe this isn't an indoor spawn. That's definitely an indoor spawn, but my indoor spawns are, I think, 20% chance. Like, down from 50% or something. Or maybe it was down from 30%. I don't remember what the old values were, but I do remember I don't want to see that many indoor spawns. And I elaborated on that in the first day, anyway. I don't know. Let's just tuck away our cash. Why not? Wonder if we can spend cash from our vehicle. That'd be neat. Just have a cash truck. It's like a guarded bank thing. Only it's not armored. Armored car. Anyways, it's not armored. Don't mind me, I'm being silly. Got stuff to put away, and then back to building. Bring Bob back to building. Sure, that's the motto. This is 100% full versus 100% full. Oh, I should have bought more solid food. Let's get some spaghetti with meatballs, why not? I gotta make another thingy. I just gotta make another sort of storage thing. So I think I'm gonna make it a storage for, I don't know, lock picking stuff. Let's see what it would take. Let's see if this doesn't let external light in. Yeah, just darkens it up inside. Guess that's close for now. Wonder if I can put anything on top of here. I could put large log sheds up here. What about a wooden watchtower? No. Doesn't let me put a watchtower up there. A smaller cabin on top of this cabin. A foundation. Okay. Yeah, so just, bits and bobs. Can put a bed up here. Nice little view from up here. What about? Yeah, that's why I called this Minecraft Evolved, because of base blocks. Anyways, I'm being silly, don't mind me. Could just put another storage shelf up here. Just have storage shelves all over the place. Weird places. Inexplicable places. Sort out storage solutions later. We're not going anywhere for a while. Not for a while, mate. Meanwhile, yeah. Another toolbox. Let's use this one. Nice. So let's pull the tractor out this way and get started. Maybe I'll have to rewind the lecture thing because there's like, what, I don't know, 30 minutes in? Maybe that's when he starts getting to his point. Drive this around for a bit just so that, you know, its energy out, its battery's looking low. Maybe I just disable battery drain for inactivity, or like drastically lower it, because it lowers even when you're offline, which is, for single players, freaking weird. It's fragging inexcusable is what it is. Yeah, just driving around before we get anything serious done. Let the battery charge up. see what's in our watchtower. Why not? Alright, now I'm going to use the bathroom and then we will get to work. All right. Oh wait, hey, I also have this. I don't know. I just took some art from the folder. I may. It's not Photoshop. It's Paint, but I may put some stuff over it later. Anyhow, where's that talk? Yeah, how energy flow shapes the evolution of life. I don't know. Let's I guess rewind it to the 30-minute mark. Roundabouts. Start from there.
About that, but I'd like to think what.
Oh yeah, these vents. It's like life came from these vents.
What I'm telling you is true. That life
That's
started
where we are right now.
in these hydrothermal vents, and they started there
Yeah, life started
because the structure of these
Anyways.
vents favours the reaction between hydrogen and CO2, the proton gradients across membranes or across barriers, because that's still how cells work. And cells now get their hydrogen from almost anywhere. So in photosynthesis, it splits water and the hydrogen is extracted from water. And it's cobbled onto CO2 to make organic molecules. But the basic reaction is hydrogen reacting with CO2 in oxygenic photosynthesis, where the waste product is oxygen. But there's other types of photosynthesis. You can use hydrogen sulfide as an electron donor. You take the hydrogen out of it, you leave the sulfur behind, you cobble it onto CO2. Or you're growing like a methanogen in the vent. The hydrogen is bubbling out of the ground, you simply cobble it onto CO2. Life all across Earth is based on the reaction between hydrogen and CO2. And you know, we go around eating things, but we're entirely dependent on the primary producers, the plants and the bacteria, which are basically reacting hydrogen and CO2. And hydrogen and CO2 don't react except under these rather careful conditions, where you have structure, the same kind of structure that we see in cells. So how common are those conditions likely to be? On the early Earth, we think that they would have been basically all the way across the seafloor, because it's a reaction between rock and water. So this is, if you imagine this is the seafloor, and then down beneath in the crust underneath the seafloor, these green rocks here are rich in minerals like olivine. So olivine is high in magnesium-rich rock, mostly found in the mantle of the Earth today, which is why you don't see so many reactions like this anymore. But 4 billion years ago, there wasn't really such a difference between the mantle and the crust, so you think these reactions would happen almost everywhere. The water percolates down to depths of 5 or 6 kilometers beneath the crust and will react with these rocks. So if you were to take a lump of olivine and put it in a bucket of water, you'd probably get one bubble in about a week's time. It's not something, you know, it's not an experiment you want to do for the kids. But at the higher temperatures and pressures down at the bottom of the seafloor, it really is bubbling with hydrogen gas. It's a pretty vigorous reaction. And that's really all it takes. It's the reaction between water and rock to produce strongly alkaline fluids rich in hydrogen gas. It's an exothermic reaction, which means it's producing heat, and so these are buoyant, warm fluids which percolate back up. And when they get to the sea floor, they react with the waters of the ocean, the minerals in the ocean, to precipitate as these vents. So the reaction between rock and water is down below the sea floor, but the vents themselves are up at the sea floor. So they should happen on any wet, rocky planet. And there's actually quite a lot of lovely suggestions from across our own solar system that they do happen. So Mars, there's traces of methane, thought to be traces of methane on Mars. Where does it come from? The wishful thinkers hope it comes from life. It's possible it does. But it's more likely that it comes from exactly this same process of rocks reacting with water. There is water on Mars still, mostly frozen and mostly beneath the surface. But you're likely to produce hydrogen and methane for exactly the same reasons. And we see on Enceladus, for example, or Europa, which are moons, icy moons, with frozen oceans. But underneath the frozen ocean on Enceladus and on Europa, it seems that there is a rather large ocean, larger than the Earth's oceans. And these plumes that you can see here are escaping from the surface of Enceladus. And they are very alkaline, pH 10 or thereabouts, and rich in hydrogen gas and methane. And so the only thing that we know of, the only geological process we know of that could produce an ocean that was that alkaline and that rich in hydrogen would be this same process. It's called serpentinization, but it's the reaction between olivine and water to produce a mineral called serpentinite, which is why it's called serpentinization. So even in our own solar system, there are at least 3 worlds where this process is actively going on. And this is really one of the places that NASA would most like to go to. Me too. And it actually also means, because of the politics of these situations, I said nobody can agree about where life actually started on Earth or what conditions. So I'm giving you my partial view. NASA like this partial view because NASA want to fly rockets to Enceladus, and they need a reason why they would want to do that, a reason that they can give, I suppose, rather than we just like flying rockets. And there may be life on Enceladus. But that means that these reasons, these ideas on the origin of life, talking about serpentinization and hydrogen and these particular reactions, is appealing at the moment to NASA. I hope that means they might fund me, but probably not. Anyway, so that's within our own solar system. If we go further afield, there's been a real drive to discover exoplanets, planets orbiting distant stars, and there have been projections now that there should be something in the order of tens of billions of Earth-like wet rocky planets in the Milky Way alone. So if that's true, all of these Earth-like wet rocky planets should be producing the same kind of vents. Water is basically ubiquitous. Olivine is we can detect olivine in interstellar dust. It's very, very common. So most rocky planets would have a fair amount of olivine in them. And CO2 again is common as a gas, an atmospheric gas. It's certainly in our own solar system. So you could imagine that these same conditions would apply really on a very, very wide scale. And so life starting elsewhere may be constrained by the same reasons. It may also require proton gradients across membranes to get going because the reaction between hydrogen and CO2 is difficult, and this is a probabilistically simple way of doing it. So if you were to find, say, 1,000 life forms in the universe, would it be carbon-based or not? Probably it would mostly be carbon-based because carbon is ubiquitous. It's extremely good at the kind of complex chemistry that needs to be done. And it comes in a convenient Lego brick, CO2. So you can build large complex molecules by adding on one brick at a time. If you start with silicon, you're starting with silicon oxide, sand. Don't try and build with sand. You want to build with Lego. So, and carbon dioxide is a Lego brick. And so if you were to find 1,000 different life forms, I would wager a bet that it's going to be carbon-based, let's say 995 times out of 1,000, and something wild and funky perhaps the rest of the times. But carbon is so common, so good at what it does, and so convenient in the forms in which it comes that it would be very surprising if it wasn't carbon-based. But then we've already run into this constraint. How do you make carbon dioxide react with CO2? I would say we're likely to find bacteria in many places throughout the universe. But what about more complex things than bacteria? I don't know how many people in this room would get very excited if there were bacteria discovered on Mars. Most
and then everyone raised their
probably
hand.
would get pretty excited about that.
I'm not saying much because, I can remember this part of the talk.
I really honestly, can we have a show of hands?
Retread and stuff.
How many people here would
I probably rewinded way too far back.
bacteria on another planet? Pretty much
Might
all
have
of them.
comments
Great.
when we listen to new stuff.
Would we find anything more complex than bacteria? We need to look back, though, and I've established what I'm suggesting is a set of constraints that cells anywhere are going to be based on reacting hydrogen with CO2, and to do it, they're going to need proton gradients across membranes. And bacteria have remained constrained and haven't changed for 4 billion years in their morphology, neither have archaea. So could it be that they are constrained by
It's acting like
the way
wall
that
was
they
actually
generate their energy? Well, I think that's probably the case. And it really is. John Maynard Smith was one of the great evolutionary biologists of the 20th century, and he was at UCL for a period. I think a lot of it's a great place, UCL, in at least in one sense, in the sense that some of the greatest thinkers and biologists of the 20th century worked there for a while. They all left and went to Cambridge or somewhere after a bit, but for a while they were all there at UCL. And I think a lot of us walk around these corridors and think, oh, JBS Haldane used to walk down here. I'd better do something good today. So Maynard Smith was one of the great evolutionary biologists of the 20th century. And he liked calling things that shouldn't happen an evolutionary scandal. He was scandalized by sex. Sex really shouldn't happen. Why would people not just make clones of themselves instead? And he spent a lot of his career trying to work out why sex does happen and why most things that make clones of themselves.
I could have sworn these things were like said earlier.
And I'd like to think
way earlier.
Actually said that the eukaryotes were an evolutionary scandal, but I think he would have seen it in those terms.
Anyways.
The problem is that all complex life is composed of this one cell type, this eukaryotic cell. And the fact that we all obviously share a common ancestor, because the plants and the animals, when you look at their cells under a microscope, they're almost indistinguishable in the sense that they all have a nucleus. They all have lots of membrane systems called the endoplasmic reticulum, for example, or lysosomes. They all have mitochondria. You could write page after page in a textbook of things that plants and animals have in common at the level of cells. But fungi have the same things in common as well, and so does an amoeba, or single-celled algae, and so on. It's a shockingly long list, and it's quite baffling as to why that would be the case. So, traits like sex as well. Lots of amoeba, in fact, pretty much all of them, are sexual, it turns out. For a long time, we assumed they weren't because you never really caught two of them together. But now we know their genomes. Funnily enough, it's the genomes that give insight into these things. We can see that all the genes that are required for meiosis, which is to say the recombination part of sex and the cell division, we find them all in amoeba. We find them all in very ancient-looking cells. And there's plenty of evidence, again, from the genomes that they've been recombining genes and changing the structure of the genome. So this is the scandal then. All eukaryotic cells share this long list of traits. Bacteria and archaea just don't do it. They don't do sex, for example. They pass genes around a bit, they do some recombination, but they don't fuse cells together, line up whole genomes, cross across genes, and then separate up. And bacteria just don't do that. So the scandal, if all of these traits, and there's hundreds and hundreds of them, evolved by natural selection, step by step, and there's no reason to imagine that that didn't happen. And each of these small steps offered some kind of an advantage. And again, there's no reason to assume that that's not true. Then why is it that none of them evolve in the bacteria or the archaea for the same reasons? They really ought to, but they don't. So you could think of eyes as a nice example. Lots of creationists say, what use is half an eye? But evolution's full of things that most people would say was half an eye. And it's exactly as natural selection would predict. There are at least 60 or 70 separate origins of morphologically complex eyes. That's not quite true, as I'm putting it, because a lot of them in animals share a common ancestor on some kind of a worm that had a light-sensitive spot. But it's partly true in the sense that the octopus eye, for example, have arrived with a camera eye essentially independently. It's convergent evolution. They started from a light-sensitive spot, and independently they ended up with a camera-type eye. There are one or two regulatory genes in common, but they independently recruited all the rest of the genes. But then there are, this is Euglena, an alga. It's got an eye spot. It's got the same proteins, light-sensitive proteins, rhodopsins, in that eye spot that we have in our own eyes. This is even more amazing. This is a camera-type eye, which you can see the lens, you can see the retina, you can see a cornea. That's in a single cell. That's a single protist, eukaryotic protist. The retina is composed of chloroplasts, just reused for a different purpose. The lens, I'm not sure what the lens is made of, but the cornea is made of mitochondria. Again, they've just been cobbled together and used for a different purpose, but it's a camera eye inside a single cell. So, my point is this is what natural selection would predict, that there should be multiple different types of eye in different environments, different ecological contexts, different types of eye with different functioning. And we don't see the evolutionary intermediates, but we see ecologically all the different types. And so we would expect to see something similar in bacteria. We would expect to see some bacteria that have something that's a bit like a nucleus, or some that do something a bit like sex, or that can do phagocytosis, go around and engulf cells and eat them. These are all valuable traits for us. So why don't the bacteria do it? It's not like the eye. There's a big difference there in what we see around us. So it really boils down to this question that I raised earlier on. What was happening down this branch of the tree of life that wasn't happening over here? And it's not to do with information, because these guys trawled through all the information and still didn't come up with the answer. And I want to make the point that it's not at the level of large plants and animals. The real difference, the real void, is at the level of single cells. So this is a bog standard alga, the kind of thing you find in any pond in London or anywhere else, Euglena. And over here is a relatively complex bacterium. It's actually even got a little compartment inside it, which some people have said is a bit like a nucleus. The reason you can't see it well is it's reference to scale. And so you don't need to know what most of these things are in here to realize that this is a lot bigger and more complicated. So these are the mitochondria. This is actually a chloroplast. You can see the nucleus there. But it's just, it's on a different scale. The level of complexity in a single cell has gone up by orders of magnitude compared to a relatively complex bacterium. Not in the biochemistry, but in this morphological complexity. And it's kind of interesting that if you were to compare two different eukaryotic cells, they look rather similar. So this is paramecium, which is a single-celled protist, and this is a pancreatic acinar cell, a human one. Again, they're roughly to the same scale, and most people would look at them and say, well, they're kind of similar. In terms of the amount of complexity going on in them, they're not a world apart. But this is a single-cell protist, and this is part of a multicellular organism. And just out of curiosity, anyone got any idea how many genes, by genes I mean protein-coding genes, paramecium has? Any thoughts?
Twice the amount of humans.
Exactly, twice the amount of humans, 40,000 genes. Now, maybe we do lots of additional regulation, or maybe we're just not very much more complicated than paramecium. But the point is, by most objective measures of complexity, there is not a great world of difference between these two types of cell, in terms of the number of genes, in terms of the amount of morphological complexity, in terms of the basic hardwiring of it. The real difference is between bacteria and single-celled eukaryotes, rather than between single-celled eukaryotes and large multicellular organisms. So I'm going to have to, rather than exploring all the possible options, I'm going to tell you what I think the answer is. Otherwise, we could be here all the rest of the week. Here's a group of cells that are pretty simple as eukaryotes go. This is Giardia. Giardia causes explosive diarrhea that anybody who's been walking in the mountains in America may have had Giardial poisoning. I never had it, but when I used to go walking in the mountains and places like that, I used to be terrified that when I drank from the mountain streams, I would get it. But it doesn't have any mitochondria. And people thought it didn't do sex either until quite recently, when it turns out it is sexual. And it turns out that it does have mitochondria too, just not as we know them. It has organelles which derive from mitochondria called mitosomes. Typical of science as well, it took 25 years of probably about at least 15 research groups around the world, not just with Giardia, but with these others as well, Microsporidia, Trichomonas, Entamoeba, Monocercomonoides. These are cells that don't have mitochondria. And for a long time, they were thought to be a kind of an evolutionary intermediate, a living fossil from very early in eukaryotic evolution that would give an insight into how complex cells evolved. Well, it turns out they're not. They're all derived. They all had far more complex ancestors in the past, and they kind of evolved down in complexity to become more like bacteria. And so they all have mitochondria, and it took 25 years of these research groups around the world to nail that. The reason it was done, in part, is because half of them are parasites, and so they're of medical interest. And as soon as things become of medical interest, then people are going to fund you. If people went to the funders and said, these are really interesting living fossils that might give us an insight into the early evolution of complexity, they're not going to get funded, unfortunately. If you say it causes explosive diarrhea, where's the checkbook? So that's what they said. They said it causes explosive diarrhea, and they had 20 years of funding, and they spent it very wisely on the early evolution of complexity. And we now know that these are actually not living fossils, but highly derived. And the one thing that we can take away from it is they all had mitochondria in the past. And that's important. It's important in part because mitochondria, as I said at the beginning, were bacteria once. And this was made famous by Lynn Margulis, I should say. She died of a stroke a couple of years ago. I only met her once. And I admired her enormously, but she had a knack of disagreeing with everybody about everything, including me. Yes, well, that man is... She was married to Carl Sagan, and they divorced after a while. Before she wrote her famous paper in 1967, they'd already divorced. I'd love to have heard their breakfast conversations between those two. But anyway, she was the person who really nailed the idea that mitochondria were bacteria once. She nailed the idea that chloroplasts derived from bacteria as well. And she also argued for a long time that there were lots of other symbioses, for example, with spirochetes bacteria giving rise to the cytoskeleton and the flagella and so on. Nobody agrees with her about that. And she was very strong-willed and disagreed with most people about most things, but she was bang on for these central ideas on the origin of the eukaryotic cell. And the amount of, I suppose you call it hate mail now, that she got, if you read the literature from after her paper in 1967 through into the early 70s, people did not like these ideas at all, and they wrote really unpleasant diatribes in the literature. You can understand why she became very hardened to abuse, and eventually basically believed everybody else was wrong apart from her. She was asked once, does she enjoy being so controversial? And her answer was, I don't think I'm controversial, I think I'm right. I'm not even sure she used the word think. So that's Lynn Margulis, and she nailed that mitochondria derived from bacteria. And we still can't really agree about exactly which kind of bacteria were they, but probably something like Rhodobacter that we're seeing there. So something acquired these bacteria that went on to become the mitochondria. And again, there's been no agreement about what kind of a cell that was until quite recently. And this is a place called Loki's Castle, which is just off the coast of Norway. And a Swedish group have been trawling around in the muds underneath there and sequencing everything that they found in those muds. So we've never, even now, seen what these cells actually look like. This is what's called metagenomic reconstruction. So you sequence everything, you try and piece together genomes by effectively matching the enzyme, and eventually you put together the genome of these cells. There's a certain amount of debate about whether there's contamination in there, but it looks broadly true. And the thing which is really surprising about it is eukaryotes are here. This is another tree, and right next to them, all these. So we started out with a Loki archaeota. They were discovered at Loki's castle, and since then various others have been found, and they've kept going with this Norse theme. So now we've got all the Norse gods down there. We've got the Odin archaeota, and the Thor archaeota, and the Heimdall archaeota, and so on. But the thing which is really plain is that eukaryotes are branching right in the middle of those groups. So whatever the host cell was that acquired mitochondria, it was something pretty similar to this. And the irony is we don't know what this looks like. We don't know what kind of a cell it was. Some people say it was a primitive phagocyte that kind of tried to eat things. Other people, including me, say, oh no, it wasn't. It was an autotroph. It used hydrogen gas. I don't think we can really be very sure yet what kind of a cell it was. But it was probably basically a fairly simple cell. And so this is another tree which I think is beautiful. This is from one of the most, I think, brilliant biologists operating today, a guy called Bill Martin. He also has a knack of winding people up. And this tree goes back to 1998. And it's remarkable for several reasons. One of them is that it's now more right than it was then. So in 1998, when he put this forward, I think most people must have thought he was bonkers. Look down here. We have two separate origins from a hydrothermal vent. These are the bacteria and the archaea. I haven't really gone into the details of that. When I first heard him say that in 2002, I thought he was completely bonkers. I now think he was absolutely right. I haven't really had time to go into why they would. So they share a common ancestor, but down inside the vents. The other thing which is really clear on here is he has a kind of genomic merger going on. So genes from the archaea and genes from the bacteria are fusing together here.
Yeah, let's just use that. Why not?
And this is singular endosymbiosis. This one is the chloroplasts. So this is not really the same as Lynn Margulis, who had lots of these things going on in all kinds of different cell lines. This was a singular event that gave rise to eukaryotic cells. And later on, the acquisition of chloroplasts gave rise to plants, but it didn't change anything really about the big structure of eukaryotic evolution. Plants are the same type of cells that we have, except with chloroplasts added in and a vacuole. But, you know, we're basically the same. So Bill has this singular origin of complex life. Now, a lot of people really hate this idea, and I think it's in part because we don't really like the idea of freak accidents in science. It kind of almost puts itself beyond science. You can't study statistically an accident, a singularity, but you can think about it in a very productive way. If this was the origin of the eukaryotic cell, then it started something like this. This is the only example that we know of bacteria living inside another bacterial cell. So there's plenty of bacteria living inside our own type of cell, eukaryotic cells, but it's really rare for bacteria to be inside another bacterial cell. This is not a phagocyte. It didn't engulf the cell to get in there. It's got a cell wall around it. It's actually a cyanobacterium, and you can see the photosynthetic membranes here. So we don't know what they're doing there. This actually is an old discovery. This is from 1979, when they were still called blue-green algae in those days. And blue-green algae really refers to eukaryotes, so everybody ignored that paper for 20 years until it turned out they were actually bacteria with bacteria inside. And so this speaks more about the whole sweep of evolution. Why would that make a difference? Well, the cells that are living inside, they are bacteria, they are cells. They've got their own agenda. They want to grow, they want to divide, they want to... There's a lovely quote from Jacques Monod, who said that the dream of every cell is to become two cells. And so that's what these guys are dreaming about in here. They're thinking, how am I going to double? And the way that they do it, if you imagine a population of bacteria, and they're all growing frantically, and the speed at which they grow depends on the speed at which they can copy their genome as much as anything else. And so the smaller the genome is, the faster they can grow. And cells that, you know, if there's something about the environment that means they don't need this gene now, it's not useful, and they lose it, they delete it, then they can probably grow a little bit faster because their genome is just a little bit smaller. And over a couple of days, bacteria, their growth rate does depend on that kind of factor. But then the environment changes again, and whatever it was that gene did, you need it again now, and so they pick it up. What bacteria do is they pick up genes by what's called lateral gene transfer. It's like passing loose change around. They acquire it again, and before you know it, you're back where you were. But if you've got a same population of bacteria living inside another cell, they do the same thing. They throw away genes that they don't need. Imagine that those genes are for making a cell wall, and you're living inside another cell. And you know, you don't need a cell wall for protection inside another cell, or for prevent yourself exploding with the difference in pressure between the outside and inside. So you lose those genes, you grow a little bit faster, you come to dominate the population. But so long as the cell doesn't die that you're living in, you'll be all right. You never need those genes again. And so there's a tendency for bacterial parasites to lose genes and to become simpler. And not just bacterial parasites, we see the same thing with Giardia and so on. And a very nice example is rickettsia, which a few years ago people thought was very closely related to mitochondria. It's probably not so closely related.
Oh man, it's right on the
It's
border.
still a beautiful example. It was the cause of that wiped out the armies of Napoleon on his retreat from Moscow. And it's spread by these ticks, and it's a bacterium. Here it is invading a large eukaryotic cell. I think it's actually a kidney cell. And the one thing about it which stands out is it's got a tiny genome. It's around about 1 megabase genome. And that's true for all of these things. I'm not just hand-waving here. This is the range of genome sizes of free living bacteria. It goes up to around about 12 megabases now. This guy, T. Ryan Gregory, did a lot of work on genome sizes. And down at this other end, these are the parasites and the endosymbionts and obligate symbionts. They're pretty much down at less than 1 megabase of DNA. So just for comparison's sake, we have 3,000 megabases of DNA. The largest bacterial genome is 12 megabases of DNA. And some large algae, like Euglena, are up to 100,000 megabases of DNA. So we have quite constrained genomes in comparison with some single cell. The largest one is a thing called amoeba W, which it was miscounted. It was originally 670,000 megabases. It's come down to 150,000 last count. But still, it's very, very substantially bigger than our own genome. But what happens with these bacteria that live in other cells? They lose genes. They become simpler. They whittle away. And that's what ended up with the mitochondria. All these mitochondria that we have in millions of copies, they all have genomes of their own. And they're passed on down the maternal line from mother to daughter. Mother to son, but my kids don't have my mitochondria. They have my wife's mitochondria. It's a very strange arrangement that I won't go into now. What it means is that if you want to be bigger, more complex, and spend more energy, it's not just a case of having a larger surface area. You've got a whole unit here. That unit has some genes which in some way control respiration. It's got the protein building factories, the ribosomes. It's a unit, and if you want to expand, you just make more units. You have more mitochondria. But it's not just that you're increasing the surface area, you've got genomes with each one. And that allows you to expand up on a massive scale. And the person who's, I think, done more on this, again, going back to the early 1990s, John Allen has been arguing that they require genes to control respiration. And still, I would say the majority of the field is not persuaded that he's correct. He is correct, I'm sure of that. But it takes an awful long time in science for sometimes the simplest ideas to catch on. Most people just don't really care very much, I'm afraid. But it's the difference that they can, to become a very large cell, you just scale up mitochondria. So this is a giant bacterium, and there are a few around. And these little white dots here are the copies of the complete genome. So the giant bacteria that do exist, it seems that they also need genes to control respiration. And this is the edge of the cell, and this is the plasma membrane where respiration is taking place. And they have as many as 200,000 copies of the complete genome. And each genome is a normal-sized bacterial genome with 3 megabases of DNA in it. And this is a eukaryotic cell. The blue is the nucleus, where it's the main gene depot. And all these little, the green spots here are the mitochondrial DNA. So there are hundreds or thousands of copies of mitochondrial DNA. So the difference between these two cells is not that this cell has an awful lot more DNA than that cell. They actually have a similar amount. It's that in that case, it's got a kind of genomic symmetry. There's thousands of copies of the same genome, exactly the same genome. Whereas here we've got one massive nuclear genome which is supported energetically by this kind of
Let's see.
endpoint,
Can they
thousands of mitochondrial genomes.
Can they
which
path
whittle
out of
down and become smaller and smaller and more streamlined. So
looking
all the
like no.
mitochondria effectively
Which
is
means I should even be safe in
multibacterial
there.
power without the bacterial overheads. And that's what allows all those overheads can go into supporting a massive nucleus full of genes. At least it's the raw material for natural selection to operate on. And so we have a kind of genomic asymmetry. And to me, that's the real difference between bacteria and large complex cells. We've got two genomes. There isn't such a thing as the human genome. There are human genomes, the mitochondrial genome and the nuclear genome. This is the last slide. Why then is complex life so rare? Why did it only happen once on Earth? And would it only happen rarely elsewhere in the universe? There's a double bottleneck here. One of them, we have to get bacterium into another bacterial type cell to break down this issue with membranes and scaling. So you've got to have cells within cells to be able to scale up. But those cells have their own agenda. You have what's called conflict, levels of selection conflict, that the bacteria inside want to grow fast and perhaps make their host cell fuse with other cells or whatever they want to do. The host cell itself wants to keep them under control and bleed off the energy, but they don't want them replicating at any old speed. Chances of it going wrong is really high. And maybe this is why we don't see any surviving intermediates. Maybe they all died because it was a pretty dodgy situation for a long period of time, or even a short period of time. It's just that this is a long evolutionary distance. And regardless of whether what I'm telling you is right or not, this long evolutionary distance, there are no evolutionary intermediates that have ever been found. And so all of this complexity...
Okay, we'll try 3 drinks of this stuff.
We have no idea yet, at least the difference between ideas and serious scientific knowledge where we can say that there have been experiments done and real data.
36 grams of alcohol, and we can handle
and if we
about
want to
200,
understand
right?
medicine and what goes wrong in
So
our
we should
own
get.
bodies, and we don't understand
It should be fine.
why these parts arose in the first place. What were the evolutionary driving forces that made them evolve? How can we really understand ourselves and medicine? And if this starts out with mitochondria in a very simple cell with none of that complexity, the nice thing from my point of view is that perhaps all of this complexity arose, and the reason that we share such similar cells with plants and with algae is not that we were all adapting to different external environments, but we all were adapting to the same internal environment, the problem of having cells living inside us. And it's that drove all of this complexity. And once it became a stable system, then eukaryotes could spread out and take over the rest of the world. And with that, I'd like to say thank you very much. This work has been done by many people, and it's great fun having a lab with so many bright young people coming through it. It's an inspiration for me. Thank you very much.
Gresham College presents The End of Space and Time.
The end of space and
Professor
time.
Robert
Wow.
Dygrath, the University of Exeter.
I don't know what that's going to be like.
My name is Michael Mainelli. I'm the Emeritus Professor of Commerce and one of the Fellows and Trustees of Gresham, and I'm here really to welcome Robert Dygrath to the UK today and to give his talk on the end of space and time. You'll wonder what a mere businessman has to say about physics, and the answer is not a lot, but I did do a little bit of postgrad physics at one point, so I was very interested when we contacted Robert about coming over and talking to us about some of the more exciting things that are going on in the boundaries of physics. And as you'll gather, over the last year, it's only gotten more and more interesting.
I wonder if the jacket
Willie
stopped the
Whitelaw
bullet.
famously said at one point,
maybe
I
I just
do not
missed.
intend to prejudge the past, but I do intend to prejudge this lecture. Gresham College has been built over many years on an openness towards overseas learning, and in particular, a very strong relationship with the Low Countries, because Sir Thomas Gresham himself maintained a residence in Antwerp during his life and was trading. The Royal Exchange is really just a mimic of the Antwerp Bourse. The Royal Society, founded here in 1660, had lectures on botany, physics, mathematics, and linguistics, all delivered by Dutchmen. And we continue today with recent lectures, including one on Gresham College in Antwerp, given by Guido Marneff a few years back. In one of my lectures, I rather arrogantly said, or used, a quote from John Archibald Weaver: "Time is nature's way of keeping everything from happening at once, and space is what prevents everything happening to me." And I use that actually to talk about the concept of a great timeless and spaceless trading bourse and what that might mean. But I think what we're seeing today is Robert's come over to explain to us about what space and time might really mean. Robert is a distinguished university professor, as you'll well know, mathematical physics at the University of Amsterdam. From 2008, he's been president of the Royal Netherlands Academy of Arts and Sciences. Robert studied theoretical physics and mathematics in Utrecht, where, after an interlude studying painting, I hear, he obtained his PhD under the supervision of Gerard Tufte in 1989. And Gerard Tufte's daughter happens to be with us today. Robert's a member of a research group that works in string theory, quantum gravity, and the interface of mathematics and particle physics. He won the 2001 Physica Prize of the Dutch Physical Society and the 2003 Spinoza Prize, the highest scientific award in the Netherlands. Earlier this month, he was also awarded the prestigious Comenius Prize for creating more public awareness of mathematics and science and bridging the gap with the arts and humanities as a columnist for Handelsblad and Folia. And finally, in July, Robert will become the director of the renowned Institute for Advanced Study at Princeton. I commend you, Robert Dijkgraaf.
Thank you so much, Michael, for this very kind introduction and for the wonderful opportunity to speak here. It's an institution that has such a long history in public outreach of the sciences. I think something that we cannot do enough. Today I will tell you kind of a grand story, which is our thinking of space and time, and in some sense, what is the role of geometry, mathematics in understanding the universe. And this goes back certainly to the beginning of modern science. This is a wonderful image of Galileo, of a book of nature that is being read, but before to read it, you have to know basically the language in which it's written. And for Galileo, this was the language of Euclidean mathematics, triangles, circles, and other geometrical figures. And I think this is a long tradition. If you go back in more recent history, for instance, Richard Feynman, the famous particle physicist, he has said that if you really do not know mathematics, don't be worried, there won't be many equations today, but if you don't really know mathematics, you can't get across the real feeling of the beauty of nature. Now, Feynman's also famous for having said that if all mathematics disappeared today, physics would be set back exactly 1 week. So, and I always thought this was a very clever remark until a famous mathematician gave the right response to this and said, well, this was the week that God created the world. So I say 2-to-1, mathematics to physics. The amazing thing is that the kind of mathematics that we're talking about today is in some sense very far away from our everyday intuition. We talk about the very large-scale structures in the universe, the theory of relativity, the very small-scale structures, the quantum theory. And I think we're living an amazing time where these two concepts are actually coming together. It's really this snake biting its own tail. And that's actually happening right in that time that we are now in the history of science. Now, if you see space and time, which I will at the end proclaim to be kind of near to their end, of course had quite an evolution of themselves. Kind of space started say, among the Greeks as basically something infinitely rigid, basically like a big stage on which the natural phenomena would play their parts. And time, according to Newton, was this kind of big clock that would tick and actually would set the stage directions. Now this image of this kind of directed play kind of really changed very much with 100 years ago when Einstein came, and he famously said, of course, that time is the fourth dimension. Now, it's very difficult to visualize 4 dimensions, but let me just help you to get across this image of this extra dimension. The best way to do this is think of a movie. So if you think of this movie, it's 2-dimensional, and think of the individual pictures that make up the movie reel. And I'll put these pictures on top of each other so that you basically get a stack of pictures. Now, if you follow that, you see that a single particle will actually become a line in this so-called space-time. And that's what Einstein said. Kind of mysteriously, all of this form one continuum, which is pictured here on the right-hand side. And everything that moves, or not move, will have these kind of spaghetti strands that you see here on the right-hand side. So we're all now kind of moving in this kind of space-time continuum. And Einstein says basically this is the object that we want to study.
What we need to build
So anything you have to say about space, you're basically also saying about time. And this went on. Not only we had this kind of unification of space and time, but the next ingredient was that space, the stage, so to say, is not rigid, it's flexible. It can curve, it can shape, and it does so under the influence of energy and mass. And that's the phenomena that we call gravitation. So anything that carries mass or energy will curve the space and time around, and thereby space and time became no longer a stage, but an active player in the game. Space and time are something which have physical properties and that feature in physical laws. And in fact, it's the influence of this curvature that describes the motion of particles under the influence of gravity. And this was kind of the grand scheme that Einstein had. That basically all of physics in his persuasion was geometry. And I think his claim of his intent in life, particularly in the latter parts of his life, was to put everything in this geometrical form. Also the theory of elementary particles, which in some sense was a very fruitless effort. And one of my conclusions today, well, this is also not the line of argument that you want to follow, because in some sense, quantum theory will kind of probably be victorious over the underlying ideas of geometry that were so dear to Einstein and all of us, actually. Now, of course, Einstein was the first one that actually was able to do a computation that nobody did before, again in the history of science, namely compute what happens to the universe. He could put the universe in his equations, and he, of course, saw that the universe was expanding, and he could also conclude that the thereby in the past would have been contracting and getting basically an inconsistent conclusion. Namely, there should be a moment where space and time started. And when he discovered this, he said, it's such a bad thing. The only thing that I now have to do is to change my theory. So famously, he took his equations, which roughly in words say that the expansion of the universe is driven by the matter and energy and the curvature of space and time, and he added a so-called correction to it, which he called the cosmological constant, with the Greek letter lambda, to just stop the expansion of the universe. Well, later he called this intervention his biggest blunder, because this was something that at that time he could have made a wonderful prediction, namely, I predict that the universe is expanding. And please, astronomers, look and see this phenomenon. He did not. But with Einstein, anything he did was brilliant, so even his biggest blunder was brilliant. We'll see this in a moment. Of course, so 10 years later, roughly, the astronomers, Hubble in particular, sees that indeed the galaxies that we see in the sky are expanding, the universe expanding, and the first proof of this so-called Big Bang theory finally comes in the 1960s, when these two engineers with a microwave telescope or receiver, Penzias and Wilson, discovered the first, so to say, light emitted at the Big Bang. That's the famous cosmic microwave background radiation. And I never really did the calculation myself. Apparently, if you take your television set and disconnect it, and you see this kind of static on your screen, then 1 in 100 of these pixels is actually turned white because of a cosmic background radiation. So actually it's the cosmos influencing with your television reception. And it's amazing that these are photons, particles, that traveled for 13.7 billion years to hit your television screen. That's just, of course, a very special effect. Well, now I think the evolving universe, the Big Bang, is part of our culture. And in fact, these images and the discoveries that are made are getting more and more exact and precise. We're living in the age of precision cosmology. And for instance, satellites, like this WMAP satellite, make these very beautiful pictures, which are kind of celestial globes, as they made in the 16th and 17th century, where you had the zodiac. But now it shows the very early universe, the first light that was emitted by the universe when 400,000 years after the Big Bang, it became transparent. And you see these small fluctuations here. They, in some sense, led to everything you see around. It's like a pointillistic painting. And I have to say here that, you know, it's signed. It's SH, it says. for Stephen Hawking. I think we have noticed this. And you see, once you see this, you can never unsee it anymore. I think that's the point. Here it is. And in fact, if you you can now make a beautiful animation. I hope this will work, where you actually can take this 13.7 years of evolution in a few seconds. You see how the first small variations of energy distribution clump together. They form, in the beginning, very violent galaxies. Then these galaxies form, and a lot of stars, modern forms of stars. And finally, you see also that this structure in the universe has a very particular nature, the kind of strands going through space. And now we have in the beautiful position that we can kind of reconstruct these 13.7 billion years of history. And we have a very precise, in the order of 0.01 sometimes percent of the description of this particular cosmological evolution. Now, of course, this is a wonderful statement that actually shows the power, in some sense, of also of Einstein's ideas. I think now, 100 years later, we are in a position to make experimental verifications of all the initial concepts that he introduced. Now, there are still lots of questions. For instance, there's this question of why is the universe so flat? It's basically a flat universe. Why is it so large and full of structure? And also here we have some good ideas why this is actually the case. And this has to do with the fact that before, at the very, very beginning of the Big Bang, just after the Big Bang, there was a period where the universe was also expanding, but was it actually at a very kind of violent rate. This is the so-called inflation, cosmological inflation, which is something very different from the economic inflation, in the sense that it adds roughly 26 zeros to the size of the universe in a very brief period. So we believe that the universe, in the very, very, very beginning, and then we talk about really fractions of a second, expanded gigantically and produced, so to say, this kind of random pattern that we now can follow very beautifully through the equations of cosmology to see how it shaped our universe. Now, the amazing thing of this picture is that it, in some sense, is a gigantic microscope. It takes the world of the universe as a kind of a magnification of a very small patch of something that was there before. And this thing that's there before, this kind of randomness, is something that really belongs to the theory of quantum mechanics. So we feel that in order to understand the very beginning of the universe, we have to understand the laws of the very small elementary particles quantum theory to describe the structures that we find there. So to find any kind of solution to the kind of grand picture of the universe, we have to study the very small, the quantum world. Now, in the quantum world, it was not obvious for a long time that the intuition that physicists have had for many, many centuries, that namely mathematics is the appropriate question to understand structure, actually is working. In fact, if you see pictures like this that are coming out of particle accelerators, look like a big mess. So is there any kind of beauty, is there mathematics behind this? And in fact, if you go to, for instance, the 1960s, there was a period where people were actually arguing there's no such thing. Kind of the elementary particle physics is like a black box, something you cannot open, something comes in, something comes out. You can study the correlation between the two. At that time, it of course was kind of the hippie period. People were thinking kind of a holistic point of view. And declared in principle that this black box could not be opened. Now this was historically speaking a kind of famous last word, so to say. Because not only could this box be opened, it turned out, inside it was in fact quite a small formula.
Yeah,
so this is my way of writing the so-called formula for the standard model, which is our description
he's swaying
of
even
the
while he's laying down.
Fundamental laws of particle physics. And this is all written in formulas that you could give a lecture to a mathematician who would know a single thing of mathematics, but would understand that these are natural geometrical objects. So again, it's geometry that's in a very deep way responsible for it. Of course, if you take an actual physics course, then you get something like this, which is just the first equation is a compact way to write this big mess, but it's even much better because, so to say, the standard model of particle physics is something that kind of fits on a t-shirt. Right? There's a handful of particles. It's a very natural way in which they interact. And I think it's one of the great triumphs of modern physics, that in fact this single equation or this t-shirt is able to describe all the physics that we see around us here. All the matter, all the forces, all the radiation. And of course, if you look at that, say that t-shirt, look at this distribution of particles, are basically two feelings that a physicist had. One is absolute beauty and elegance. Amazing that the world works like this. And the second feeling is what was once expressed when one of these particles was discovered. Physicist Rabi famously said, "Who ordered this?" So you look at this and you say, why? Why quarks? Why this funny phenomena that anything in nature seems to come in three so-called families, small, medium, large? Why are there three colors of quarks? There are lots of questions, why questions that typically a child would ask. And of course, these are good questions in the sense they have questions that basically do not have an answer. Right? Physicists basically at a loss. And they try to figure out whether this fits in a grander pattern. So if you start to rearrange the pieces of the puzzle, then for instance you can see that you can rearrange them in more symmetric patterns. I've pictured here one, which seem to suggest that this is just part of a bigger story. There are bigger symmetries here that we can't see in nature, but that perhaps are behind the physical phenomena that we see. Now, nature has given us a few clues that indeed this is not the end of the story. And perhaps the most famous one is again coming from cosmology. You definitely must have heard about this, the existence of dark matter. If you look at the way in which gravity is acting on the stars in a galaxy, then astronomers have discovered that in order to count this in terms of matter, there's a huge cloud of matter which is dark, invisible, and not made out of the particles that we know surrounding each galaxy. And by indirect measurements, you can actually determine the structure of this dark matter distribution. Roughly 6 times more of that dark matter than there is original matter. And for instance, so all this thing which is shaded blue is artificially added, say, to this picture. You can't see it, but it seems to be there. And it's enormously important because of the structure of the universe. Cosmologists, they look at the structure of the universe. So each of the little dots you see here is a galaxy. And as we saw in the small animation, these galaxies are not uniformly distributed to the universe. They're clumped together in some kind of large-scale structure, these kind of strands that fly basically through space. And by studying the dynamics of matter and dark matter, actually get a very clear model that seemed to fit very well the observed structure of the universe. So we know there's lots and lots of more matter around that we can't encode at this moment in our physical models. And even it's worse. The last couple of years there has been a great survey of cosmological phenomena, particularly also of supernovae, which are stars exploding in galaxies. The moment such a supernova explodes, it's roughly as bright as a whole galaxy.
I think it's calming
and
down
there are
enough.
large surveys here. Each of these pictures is a supernova that's been found the last few years. And by looking at these supernova, there are kind of little bombs, they're enormous bombs that go off with kind of a fixed amount of energy that gets released. So by knowing where the supernova is, and you know basically how much light it would produce, you can get a very good measurement of distances in the universe. And the great conclusion of this is that the universe is not only expanding, it's expanding in an accelerating way. So it's like it's only getting faster and faster, and there's a force that actually is pushing the universe apart. Now this force, which cosmologists call dark energy, is exactly this parameter that Einstein introduced, the so-called biggest blunder, the extra physical phenomena that he conjectured to hold back the universe. In fact, it's there, but it's working just the opposite way that Einstein figured. It's not slowing down the expansion, it's actually adding to the expansion. And in fact, this has dramatic consequences in the sense that in the end, the universe will be expanding so fast that most of the galaxies that we see now will actually be far, far away, and we will actually in some sense look in a dark void. Now, this was, of course, an equation and a result that got lots of attention. Last year's Nobel Prize was, in fact, awarded to this phenomenon. And I guess you also know the consequence of this, which is that physicists are in this wonderful position that they know exactly what they don't know. So 96%, according to these computations, of the universe is either in the form of the dark matter or dark energy, which is just a fancy way of saying there's some physical phenomena that we don't understand, but we see its presence. And only 4% of the universe consists of particles that we describe in our textbooks and that we teach in our lectures about. I often ask people in other fields, what's your percentage of dark matter? How much do you know that you don't know? It would be very interesting to ask this question in economics. Of course, there's also the so-called unknown unknowns, which are things that you don't even know that you don't know them. And that, for instance, this dark energy was in that category 10 years ago. Because basically every cosmologist at that time would have claimed that this 4% was everything. So only now we come in this kind of very modest position that we only have to find this another 96%. So I always feel that cosmologists and physicists are a little bit like these old people map makers who charted some part of the territory because there was a large part which was unknown. And of course they're very difficult to leave that empty. So they sketched all these kind of sea monsters there to be there, right? So these are kind of dark energy and dark matter are kind of the sea monsters, I think, of present-day physics. And perhaps the physicists are in this little boat trying to figure out whether these monsters are really there. But we're still mapping it out. Now, what could be the possible explanation of these effects? These big question marks that are, so to say, in the sky. And to answer that, I want to go back to a completely different question that perhaps some of you have asked once. So if you learn about elementary particles or molecules, you are told what the property, for instance, of electron is. So how come that every electron has exactly the same properties? If there's a machine making this, if there's a factory, then actually it's a perfect factory. It makes these individual particles exactly the same. Now there's a good answer to this, and this answer was actually given by John Wheeler, you just mentioned him, in a telephone conversation to his then graduate student Richard Feynman. And Feynman describes this in his Nobel lecture. Feynman would win the Nobel Prize basically because of this idea. Wheeler calls him up in the middle of the night, asks him this question, and asks, I know the answer, because there's only one electron in the whole universe. Now, I always feel that if your thesis advisor is calling you in the middle of the night, you have to be wondering what he was drinking, but actually this is typically Wheeler. This is a crazy idea that is kind of crazy enough to be true. Here's Wheeler. So this is this little particle. This is space. Time is going upward. And Wheeler was saying, suppose this particle could only go up in time, like we are now doing, but could go back in time. If I could go back in time, I could re-enter this room, stand next to myself, and would be an exact copy of myself. Exact, really, to the last digit. And I could do it another time. So Wheeler was saying, suppose this particle could go up and down in space and time, and make a big knot. What would this signify? Well, if you would think of this as a stack of pictures, on the bottom you would have a single particle, but in the middle you would have many, many particles, going up and going down, which have exactly the same property, because it is the same particle.
I don't know, it seems like...
So I think it's a very clever idea. Feynman immediately said,
me.
well, then you would have as many particles as antiparticles, but now these pictures are known as Feynman diagrams. So Feynman really took full advantage of this so-called space-time picture of particles, how he described it. And in fact, reality is even more strange. For instance, a particle can do the following thing. According to these rules, it can split in two particles for a very brief time, and then these two particles are combining again to another particle. These intermediate particles are so-called virtual particles. You can only see them indirectly. It's basically this rule of quantum mechanics that anything is allowed as long as you do it fast enough before it can detect it. I always feel this is something very typical to the Dutch mentality, I think, because basically our whole society is based on this description, our so-called tolerance. And in fact, but these things happen. In fact, they are measured in particle accelerators, and there's the ultimate result of this, which is that for a brief moment of time, two particles can appear out of nothing, of course violating every rule in the book, and then they combine again. Or if you wish and you want to think like Wheeler, it's a single particle that goes up in time and down in time and keeps on going round and round and round. This is not some kind of science fiction phenomena. This is something that's happening right now here in this room and can be measured in a laboratory. In fact, the Dutch physicist Casimir, after which this effect is named, measured this in between two electric plates in a slightly different context. So empty space, according to quantum theory, this is my own kind of visualization of empty space. It's kind of this boiling pot of particles and antiparticles appearing and disappearing. So space-time is not only can be curved, can be shaped, it's also full of life, so to say. It has really a physical material that you can study. And if you take a chunk of this quantum space-time, because of all these phenomena, there's energy in it. And this energy, according to quantum theory, that's this dark energy. That's the phenomena that cosmologists measure. So I like to joke that kind of empty space, the vacuum, is the most fascinating thing to study in physics. But of course, writing big grand proposals to study nothing might actually not come across very clear, but in fact it's what we're doing. The big mystery is really, so say, the old-fashioned ether studying nothing, studying space and time itself. And as we see, it's really the place where these two theories come together. So what we are studying is a thing called quantum gravity. How does space and time behave in the quantum world? And we know there is such a thing, because if you look at the various forces of nature, the three forces that are there in the standard model, and you compare them to gravity, you see that when the energy scale goes up and up and up and up, that gravity basically gets the same kind of the same strength as the other forces. So there should be a moment, even before this very brief split of a second in which inflation starts, where space-time itself becomes a quantum phenomenon. So not only are the particles themselves allowed to do anything they want, space-time itself is allowed to do this. And therefore it basically stops. Max Planck, the father of quantum mechanics, in his first paper ever written on quantum theory, immediately realized this. He realized that if quantum mechanics was there, ultimate consequence would be that there is a smaller size in physics, a smaller size to space and time. It's a little bit like you take at this picture, which is, it's just, it consists of pixels on a computer screen. So if you zoom in and zoom in, you see at some point you get to see these pixels. And basically what physics is telling us, that space itself should have this property. If you put it on a gigantic microscope, there's no longer space, there are little bits, there are pixels. There are quantum bits roughly the size of this Planck length. Now this Planck length is incredibly small. If you look at the various scales in physics, there's a smaller scale, which is the Planck scale. There's a larger scale, which is the size of the visible universe, the Hubble scale. And if you go from left to right, from the smallest to the largest structure imaginable, there are 60 steps of a factor of 10. And one way to kind of visualize this is right very convenient in the middle. So the geometrical mean of the two is the scale, it's roughly a 10 micron, it's the scale of a human cell. So if you want to think of how small the Planck scale is, take the whole universe, make a scale model of it, as small as a bacteria. And now think of a bacteria inside the scale model of the universe. It's incredible, because the most incredible thing is that this stops. There's a larger scale and there's a smaller scale. That means that in some sense, putting this under the microscope won't help anymore. There's no way in which we could get to smaller structures. Now, where do we see these phenomena? Is this relevant to physics? And then I think the amazing thing is that there's a kind of a laboratory where you can test these ideas. And it's again a cosmological laboratory, and it's black holes. So black holes are something that really, were in science fiction books 20 years ago, but now are part of the standard description of our universe. For instance, there are black holes inside every galaxy we see, often millions and millions of suns, with a weight, mass of millions and millions of suns. And if you see they're extremely violent, this is a galaxy, and you see these big radio plumes coming off, which are hundreds of thousands of light years big, are coming out of this galactic black hole. And for instance, if you zoom in the center of our own galaxy, you see that the nearby stars are moving around quite violently and fast at speeds which are percentages of the speed of light, all surrounding this galactic black hole. Now, for a theoretical physicist like myself, I would draw the so-called space-time picture, and then a galaxy, and then black hole is something very particular. It's something you all know. It's a star that's kind of imploding. Its own gravitational force is pulling everything together, in the so-called singularity, where the gravitational force becomes incredibly strong. And then remarkably, this very violent area of the universe is protected by a so-called horizon. There's an area around the black hole, a sphere, if you would draw it three-dimensional, that has this property that once you're inside, you're doomed, but once you stay outside, you're fine. And the reason that you're doomed inside the horizon has to do with a completely crazy phenomena that in all these pictures, I had time flowing upward. Inside the black hole, time is flowing inward. That is, it's a spatial direction. It's flowing from the boundary of the horizon towards the center of the black hole. So if you're inside, you would typically say, well, there's like 1 meter distance to the center. In a black hole, you would say there's a 3 minutes distance to the center. That is to say, you know, you're watching a movie, and you know you have only 3 minutes to go. So you'll know it will end when you hit the singularity. Now, there's a famous set of laws that black holes obey, and that are very famous in some sense, or very familiar from a standard physics perspective. The first law is the so-called second law of black hole thermodynamics, that if you have two of these black holes and they merge together, the area of their horizons is always, of the new black hole, is larger than the sum of the two original ones. And this is something that we know in some sense from standard thermal physics, where we call this the second law of thermodynamics, which is the phenomena that entropy always increases. So black hole physicists, Bekenstein and Hawking and others, introduced a notion of so-called geometrical entropy, which is a kind of gravitational version, which is equal to the area of the horizon. And then there was the famous discovery of Hawking, that if you introduce an entropy, perhaps you can also introduce a temperature. And indeed, he discovered something quite phenomenal, that if you have these funny laws of quantum mechanics that say that particles can be created out of nothing for a very brief time, if the same phenomenon happens in the neighborhood of a black hole, you have like two particles just here at the edge of the horizon, one particle being inside, the other particle being outside. The particle inside is basically doomed and will be pulled by the gravitational force to the singularity, while the other particle is now kind of liberated and can escape to infinity. So this is one of the places where quantum mechanics and relativity interact in a very strong way is in the neighborhood of a black hole, where it leads to so-called spontaneous radiation out of the black hole. This is called Hawking radiation. And the amazing thing, if you do the computation, you find that the temperature of this thermal radiation, in fact, is given by the surface gravity of the black hole. So not only we have entropy, we have energy, we have temperature, it looks like there's something like thermodynamics going on in black hole physics. In fact, if you look at a very tiny black hole, you might say, well, it could form by matter colliding, it would live for some time, and then it would radiate out particles by this Hawking process. So if you look at a very small black hole, it would almost be like a small particle, particle as they are formed in our usual accelerators. Two particles collide and make a new particle. It could be something like a radioactive particle, so it will decay, and after some time it will disappear. So it means that if you want to make a little black hole at a certain spot and put a lot of energy in a certain space, then at some point that black hole will evaporate. So there will actually be some kind of uncertainty into the time during which this particle will live. So this already tells you that space and time are interacting in a very strange way with black hole physics. In fact, this led to a kind of a line of reasoning, which I'm actually talking about, and which goes again back to John Wheeler, who put this wonderful, he was very good in slogans, and he called this phenomena it from bit. Namely, what is it? It is the universe. And what is bit? Bit is the entropy that's there. Entropy is information. So he had this image that if you think of the horizon of a black hole, there's a kind of information inside the black hole, and you can compute the amount of information, and you find actually that that amount of information, it's like you filled the black hole with zeros and ones, with little bits of information, where you use 1 bit per square Planck length. So think of this horizon of the black hole as this kind of pixel of the picture of Max Planck that I had. And you can see how much information can you store in a black hole. Well, basically by putting one bit of information of every kind of square Planck length that you can subdivide, in which you can subdivide the horizon of the black hole. So this leads to what the physicists now call the holographic principle. Perhaps the physics of the black hole, and anything outside it at least, can be encoded in all putting this information on the surface of this horizon, which is in some sense the edge of space. We already argued that inside the black hole, space and time come to an end. But so it doesn't really end. What basically this theory says, they just cut it off, create a screen, which is the thing that surrounds the black hole, forget anything inside, and project all of physics in terms of the information on that black hole horizon, the zeros and ones that are sitting there. It's a rather radical idea, because it basically tells you that in some sense information is the underlying layer of understanding all of quantum geometrical physics. Now, can this idea be tested? It can be tested in some kind of a theoretical way. And one way is this in string theory. I'm not giving a course in string theory here, but of course you all must have heard that string theory is something where the notion of an elementary particle is, so to say, generalized to a one-dimensional object, a little bit of string. But one thing that the last, say, 10 years, a lot of research has been devoted to is studying how does string theory encode for black holes. String theory is supposedly a theory of quantum gravity, combining gravity and quantum physics in a unique way. So what does it tell us about black holes? Well, here's the cartoon version of what black holes look like in string theory. Here's the horizon of the black hole. Outside you have gravitation. And gravitation is described in string theory in terms of these so-called closed strings, these little loops of elementary loops that are running around and basically are forming the shape of space and time, the curvature of space. So we can kind of replace these closed strings by Einstein's description of space-time. Now what happens to these strings when they're very close to the black hole? Well, this is really a cartoon version, quite remarkable. You can make this cartoon into an exact mathematical formula. What happens is that these kind of strings halfway fall through. So you see here there's a half of a string sticking out, almost like somebody, so in the sea waving his hands, help. So there are these kind of so-called open strings that are, you can think of as are kind of attached to the horizon, to the surface of the black hole. So they are like tethered to, they're open pieces of string that are kind of, the two endpoints are fixed on the horizon. And you can describe this system. It's a very complicated system, but you can describe it. In fact, the mathematical description of this neighborhood of the horizon, quite remarkable in string theory, is in terms of a well-known physical theory. It's a so-called Yang-Mills theory. It's the theories that are described in the Standard Model. So in a kind of very roundabout way, the physical theories that we developed to study our elementary particles seem to be relevant also to describe black holes, but then we really have to apply them in this quantum gravity regime. So there's some kind of theory of so-called open strings, matrices of strings. I have no time to explain the details of it, but the important thing is that this is a working model, an exact mathematical model, that describes to you the physics of quantum black holes. And in fact, out of
but
this,
it's really only mathematical.
That in some sense, what we call the fundamental layer of physics, namely space and time, gets replaced at very small distances by something more involved. And in the case of string theory, actually you have a very precise candidate for this more fundamental theory, which is a so-called large N-gate theory. So there's this description, which is kind of here, it's known under the technical name of ADS-CFT correspondence, but it's very, in the caricature version, it basically tells you that all of physics in this particular model is equivalent to a theory living only on the boundary of the black hole. So in some sense, the three-dimensional physics, or if you include time, four-dimensional physics, is something which actually all comes down to this area of the black hole. And that's, of course, quite an amazing thing, because that means that one of the space dimensions, the distance that you go off the black hole, is something which is not really there in the fundamental description. It's what's called an emergent phenomena, something that comes up only in a particular limiting structure. In fact, if you look what this extra dimension is in terms of the original, the kind of the quantum description living on the surface of the black hole, you find in fact that so this is the holographic principle, so it's really like a hologram, which is also a two-dimensional picture that gives a three-dimensional reality. The extra dimension, so to say, that has to be constructed is related to the energy scale in which you probe this kind of two-dimensional system. Well, I prepared some slides how this will look in a very concrete detail. That's a so-called ADS CFT, but let me just skip that. Perhaps the most important thing to be said is that this gives you, so to say, a dictionary that translates questions in terms of geometry and gravity in terms of a completely different set of notions, namely quantum theory and elementary particles. Now, finally, I want to say something about the most kind of radical way in which this is implemented, which is a theory that got quite a lot of attention 2 years ago by my direct colleague and friend. We wrote many papers together, Eric Verlinde. And he took a kind of the ultimate consequence of this idea. He said, if really gravity is not a fundamental force, if what we call curvature of space and time is in some sense just an illusion because underlying is this more quantum description, perhaps we should stop looking for a fundamental description of gravity. And he noticed there's such a thing as entropic forces, which are there in space, are just in everyday physics. And there's a famous example of an entropic force, which is, for instance, if you take a large molecule, like a polymer or something, it can be, or think of it, you can even think of a protein or something. It can be folded in many, many different ways. And if you take a pincer and you pull on the molecule, you find a certain force. That's basically, I mean, the technical description is that because of thermal effects, this molecule can be in all kind of different shapes. And there's a technical description that the force that you feel has to do with the entropy into the system. So there are many forces in nature that are not fundamental forces. That means that there's not a little particle like the photon for the electromagnetic force, or the gluon for the strong force, the quantum chromodynamics, that's responsible for this. We shouldn't look for an elementary description. We should look for an emergent description. There should be an entropic way to reformulate all of gravity. And he made a very interesting start in this project. For instance, he had a kind of embarrassingly simple derivation of Newton's law. So it's always nice to tell about Newton's law here, I would say, so close to home. But if you look at this paper, he has a very elementary, he looks what happens to a particle if it's in the neighborhood of a black hole. You can see basically by throwing in a single particle what happens to the entropy. You can look at the temperature of the black hole, which is in some sense a thermal temperature. And again, I won't go into the mathematical details, I'm not sure that everybody could follow. But if you combine these three equations in a clever way, you get FSMLA. So he basically is doing something, I would say, very complicated, taking these most fancy new ideas from physics, and out of it producing, I would say, the very bedrock in which you would think everything was based. So he's really turning things around. But I think he has a very principal point here, because if we take these ideas from string theory, from quantum gravity, from his entropic description series, space and time should not be the basis of any of our arguments. Space and time should emerge from what we are doing. So there should be something under it. For instance, if you ask the question, what was the very beginning of time? Or what's at the very end of time? It's a little bit like asking, where is the beginning of a river? You can follow it up, you get a little mountain stream, and then at a certain point there are a few drops of water lying on a stone. Is this the beginning of the river? Well, the whole concept of a river doesn't make sense anymore. What is the temperature of a gas if it only has 2 or 3 molecules? The thermodynamical concepts stop. So perhaps there should be a more basic description of space and time, or out of which these emerge. And this goes down to a very deep argument that runs among physicists, which often is phrased as what is garbage and what is beauty. So what do physicists like? Often the word you use describing a physical theory is beautiful, or it's elegant. And where do we find beauty in science? And there are basically 2 schools here. The first school is that, I would say that's the reductionist school, and most particle physicists belong to that school. We say, well, we see basically a big mess around us, the chaos of life. But if you really go down to the fundamental laws of elementary particles, they're very elegant and simple. Only you have to start describing everything in terms of electrons and quarks, etc. So that's very neat if you have 2 or 3 of these particles. It becomes pretty hopeless if you have billions and billions and billions. But so then the idea is you shouldn't look at beauty at the large scale, beauty is at the smaller scales. And in fact, we hope, along that line of argument, that if there is even something more fundamental than the standard model, it will be even more beautiful. And Feynman described this in a very nice way. He said, often in physics, you have a beautiful theory and then some measurements don't fit, and you lose this beautiful picture, and you go through a kind of chaotic period of transition. And certainly there's a bigger picture that comes into mind. And it's even more beautiful because it explains more things in terms of a smaller number of ingredients. And that's one half of the physics community. The other half, so no, it's just the opposite way. Now take this glass of water. Now, it has very beautiful properties. It has a temperature, you can do hydrodynamics, it's transparent, you can drink it. But if you want to describe it as a chemist in terms of 10 to the 26 H2O molecules, it's extremely complicated. So the big mess is actually in the small details, and the beauty is in the large scale. The laws of hydrodynamics are beautiful equations, but of course only an approximation to this large collection of elementary molecules. So for instance, thermodynamics is one of the most beautiful theories in physics. Statistical mechanics is a big mess. So beauty is at the largest end, the largest scale. Now you see these two are kind of in conflict. And I think the lesson that we are now learning is that, well, if you really want to understand the full picture of the universe, we already seen we are forced by experiments and results to combine the largest and the smallest. So in some sense we need some kind of synthesis of these points of view of life. And in some sense, the two things that are competing here, I would say, is geometry, which is the large-scale structure, and quantum theory, which is very different. It's much more abstract, it's more algebra than geometry, and both have their own qualities. But I think if you see in some sense what is the best way to understand these structures, I think right now, all the evidence, the theoretical evidence, is pointing that in some sense, quantum theory, quantum information to be more precise, is a more fundamental concept than space-time geometry. And so in some sense the lesson that we go from the individual molecules to the properties of materials is very similar, in which that we go to the individual space-time bits, the bits of Wheeler, to kind of the space-time it, namely the space-time geometry, emerging with beautiful equations. In fact, Einstein always said that his two favorite parts of physics were thermodynamics, which had just a few lines and you describe basically all the properties of all materials, and his own theory of general relativity. And I think what we are leading to, that these two things are not only both beautiful and they are kind of analogous, they might be actually equivalent. There might be an equal sign connecting the two. And I think that it would be an astonishing fact. I think Einstein probably very happy with these conclusions. But of course it also leaves you with an enormous question, what is this thing on the left? And it might be actually comforting in some sense that the basic phenomena out of which everything is made consists of these kind of zeros and ones, which I think is also a good metaphor, I think, of our present life. But information might in some sense, according to this argument, be in some sense the very basic layer of our understanding of the universe. Well, this needs, so to say, a lot of details. I'm very much aware this is a very general lecture. I have to remind of an anecdote of Pauli. Pauli, of course, famous co-discoverer of quantum theory. And there are two quotes I want to mention of Pauli to his friend Werner Heisenberg. The first one, when Heisenberg discovered the first uncertainty principle, that an electron can sometimes be a particle and sometimes be a wave, he wrote very enthusiastically to Wolfgang Pauli. And Pauli wrote back. This is 1 week after the discovery of quantum theory. And Pauli says, well, I think I understand it. If I look with my left eye, I see a particle. If I look with my right eye, I see a wave. If I open both eyes, I become crazy. You might feel like this. Or you might feel that there's another anecdote, which when both are grand men of physics, Heisenberg, in fact, has a universal theory of the world, and Pauli is in the audience and listens to the lecture, and clearly he's not very impressed with the amount of details of this theory. So he sends Heisenberg a postcard and just has a square with an empty square. And he says, "Dear Heisenberg, this just to show that I can paint like Titian. Details will follow later." Thank you very much.
For all information, please visit www.gresham.ac.uk.
So that's shit. Next is a podcast on civilizational collapse. Fun. As far as that, I don't know. I'm still not made up on quantum physics, quantum mechanics. Used a toilet. This is what I think of your theory, Einstein. Yeah, buddy. Pick up a hammer, you fucking nerd. Chop some wood. Alright, anyways. One log you don't know what to do with. You don't know what to make out of this single log. The tree branches, I don't know what to use tree branches for. Actually, because I'm sure there are things you use tree branches to do. But, like, I have an abundance of tree branches. I just don't know what they're used for. You can use an improvised wheelbarrow. Then again, you can use a long wooden stick. What the fuck? How does that make sense? Oh, you can use a massive set of tree branches, or a long wooden stick. And it's probably like these walls too, because if you use a long wooden stick, which you can chop into 5 small wooden sticks, it counts for 1, just the same as small wooden sticks. So you're wasting 4 potential slots if you use a long wooden stick on a wall. And I wonder if it's not the same for a tree branch, because honestly, you can chop them into like way more long wooden sticks. I guess it's just, if you want to, you can use a bundle of wooden planks or a wooden plank, and why would you? I hope it fills up way more charges and that. Anyways. Let me just place it. Fill with the metal saw. I don't want to fill it with the metal saw, but I have a feeling that it's a waste to use tree branches to craft that. So yeah, basically tree branches are only there for bundle convenience. Right, you don't actually have to make anything with them. That you can also use smaller packages, which, you know, who cares, who knows why, but... I've gotta cook. So I don't know, I think this... Oh shit, no, that's not it. This is it. Could just do like lo-fi. I should have like put a very simple message like, "Oh, we'll be right back." Okay, so just, you know, for that. I'll stay on the pause screen. How about that? And I don't know. Just look up fucking fair use lo-fi, free lo-fi beats. How about that? We'll see. I'm just gonna mute for real quick, just in case, just to, you know, preview these things on my own. Alright, I think this should be alright. Just half volume. Chill that out. Make a silly little thing. Yeah, then we'll just do that. That's neat. Okay, so yeah, I'll be back. Is just nice little intermission, I guess. Intermission time. Okay, there's been a little bit of a change of plans here. It's a fairly short intermission. Whatever, though. We're just gonna keep going with our building. Listen to this other thing. Is why do civilizations collapse, and is ours next? I suppose I should be saying the title of these videos. I don't know why. Ooh, the next one's from Stefan Wolfram. Anyways, this one. Why do civilizations collapse? Our civilization is already collapsing. I hate to spoil this for you, but this came out in 2021. We're quite a bit into 2022, I'm pretty sure. And things are just getting clearer and clearer that, we're not long. Anyways, so let me undo that screen. We're back here. Start the video. Let's just log for 1.5 hours. 1.5 hours of wall building.
Samo, welcome. It's great to have you on.
It's great to be here with you.
Now, I'm especially excited for our conversation today because it feels like a blind spot to me. I really feel like I haven't studied history enough and that there's a lot to learn from it. And in the best case scenario, history should be able to help us better understand our world today, and perhaps even more importantly, better understand how we can kind of steer the future to a better world. So I'd love to dig into that with you through a number of different topic areas, starting with the topic of long history. Do you want to tell us about what is long history and why does that matter?
Long history is my approach and this general approach to studying the prehistory of society as much as we study, say, recorded history. That is, taking things such as the archaeological record and genetic evidence seriously in our understanding of how human culture has developed over the last few thousand years, but also over tens of thousands of years, hundreds of thousands of years. There are all sorts of interesting things that we can now learn about the past, thanks to new technologies, such as, Neolithic migrations, when the Americas were peopled, when agriculture first arose, and so on. In particular, I think that we will find that our civilized history is much longer and predates these written sources that are usually considered the barrier between history and prehistory. And I think that's going to be the most fertile area of development in the next few decades and might change our whole conception of what humans are.
So what's going on here? Why is it that traditionally when we think about history, we're not going back as far as you're talking about?
I think a little bit of it is due to an institutional gap. Historians are people who do brilliant work, but they usually rely on sources, primary written sources, and they work within an existing field, an existing specialty. There are several new societies that we know from the archaeological record where the archaeologists are sort of doing the work of the historians, trying to piece together what happened when, trying to produce theses of why this or that happened. But let's be honest, that's not truly the specialty of archaeologists. I greatly appreciated Klaus Schmidt's hypothesis on the history of religion and the origin of religion at the site he discovered, Göbekli Tepe. But he was an archaeologist. He wasn't a scholar of the history of religion. He wasn't a historian. So as interesting and fruitful as his hypothesis is, we really can't ask archaeologists to, rethink these social systems, even if they are the ones discovering evidence for them.
I see. And do historians and archaeologists collaborate? It seems like that might be ideal in this case.
I think it would be ideal. I think that such collaborations frequently do happen when there is already a known quantity, when there's sort of this society that you want to study. Like, say, if you wanted to study the Mississippi mound builders, it wouldn't be hard to bring together historians and archaeologists, but it starts getting a little bit tricky when you're pushing on the very edges of recorded history, right? When you're looking at something like the finds in southeastern Turkey, or finds in Qatar, or say the Neolithic and Mesolithic monuments of Europe. These are places where, there's not really established literature even. And to start a new literature is often very difficult, and you're sort of bootstrapping from the archaeology side of things rather than the historian side of things.
So give us some idea of the timeframes we're talking about. Sort of year range is usually considered civilization, and then what timeframes are you discussing when you talk about long history?
I think that the normal time frame, the consensus frame that you might find in a popular history book is about 10,000 years. Now, this itself had been revised further back into the past when in the 19th century people discovered evidence of civilizations such as the Hittites and the Sumerians. It matched until recently the oldest evidence of agriculture. However, we now have new finds such as the Ohala site in modern-day Israel that seems to show that there is evidence of agriculture 23,000 years ago. And that really should push back our assumptions about the world. Now, let me be clear. 23,000 years ago, we might have evidence of this proto-agriculture, of this simple cultivation. We don't yet have evidence from that time period of complex society. But, there's a different site that we'll discuss later that is much older evidence of complex society. So I think when we're talking about, this long history perspective, I think we're actually talking about the last 50,000 years of human civilization. One pithy way to put it is to say, even our prehistory had a prehistory.
So it seems like our intuitions today are that if something is invented, eventually people all around the world will hear about it, and not too long. Could part of what's going on here be that things were very unevenly distributed in the distant past? In other words, you could have one civilization that was much more advanced than other civilizations, and then because information spread so slowly, if that civilization failed, others may not even ever have gotten the technology from it.
I mean, we don't need to speculate. We know the world was like this until quite recently. This is obvious when comparing New World civilization and Old World civilization, right? Like all of the, say, advances of the Old World, including things that we might think of as very basic, like the use of the wheel and so on. These were not present among Native American societies. They didn't work with iron, for example, though they did have metalworking with silver, with copper, and so on in Mesoamerica. And in antiquity, of course, travel was only much harder than it was in the 14th century or the 15th century. Traveling from, one end of Eurasia to the other only became easy, and I put easy in quotation marks, after the domestication of the horse, right? Before that, the cultural exchange between, far west and far east was very limited. To this, we have to add natural barriers also, such as deserts, mountains, and then the difficulty of ocean navigation. So yeah, I think the exchange of information and technology is certainly a big reason, barriers to this exchange is certainly a big reason that we see deeply uneven development even in recorded history, and much more so in these sort of eras of 10,000, 20, 30, 40,000 BC.
Now, you mentioned agriculture. Could you talk for a moment about what's special about agriculture when it comes to civilization?
Yes, the consensus theories of civilization put the origin of agriculture side by side with the origin of complex society, or what we usually call civilization. The assumption is that once you have agriculture, you can have large population centers emerge. It's necessary to store the produce of agriculture, usually assumed to be first grain. It's necessary to protect it. It might lend itself easily to things like taxation. And so you could imagine that the origin of the modern city-state is usually considered a straightforward consequence of agriculture, right? You start seeing these city-states like Ur and Uruk emerge very quickly after we have evidence of agriculture. Now, I have to say, this was the theory until recently, but new evidence has come to light that suggests that agriculture long predates the cultivation of these grains and long predates the origin of these city-states.
Yeah, so what's going on there? How is it that you could get these two things being decoupled?
What I think is happening is that there is a long transition from hunter-gatherer societies to agricultural societies, where it's not the case that they immediately switch over to some very different mode of living. It's rather the case that, early agriculture kind of sucks. It's kind of difficult. You have to do a lot of work. It has some predictability to it, but actually, the food that you're eating is perhaps somewhat impoverished compared to the food you could be eating if you supplement it with hunting and gathering. Forests in particular might be much richer than we usually imagine when it comes to providing sources of food, and particularly chestnut tree forests, I think, in temperate climates we know from accounts of Native Americans living in California could provide quite a few calories, like a lot of calories, and we don't necessarily know how many. There's also evidence of, say, the sort of gardening and symbiosis with the forests of the Amazon rainforest as well, and the creation of artificial soils such as terra preta, which, was much more fertile than naturally occurring soil in the Amazon. So basically, early agriculture is not immediately 10x or 100 times better than the hunter-gatherer lifestyle. So think of it as agriculture, and especially gardening, perhaps being just part of a toolkit of a people and a culture that was still primarily relying on hunting and gathering and also fishing.
I've also heard it argued that it may be not enough to have agriculture generally. You might actually need very specific crops. For example, you might need crops that have predictable seasons, that can be stored for a long time. And part of this might relate to sort of taxation, that if you're going to have, let's say, a big city, you're going to need most likely some form of taxation. And in order to tax people, you need a way of figuring out, well, how much grain is each person producing? And then you have to have a way of knowing when they're going to harvest it. And they have to be able to store their grain and so on. And I'm curious what your reaction to that theory is.
I think there's a lot of truth to it, where you could even argue that, say, a system of irrigation, right? A system of irrigation especially lends itself very naturally to centralization. The reason is because a system of irrigation has to be maintained centrally. You are dealing with the entire course of the river. An alteration made upstream affects water flow, flooding probability downstream. We see this as very central in Egyptian civilization and to some extent Sumerian civilization. So perhaps it's the unpredictability of rivers, large rivers especially, both the destruction and bounty they can provide, that might be an even greater factor, even more so than the domestication of grain. Though, of course, there's fun arguments to be had about grain. I especially like the argument that bread is basically a drug, that it's mildly intoxicating. So once you start eating bread, you keep craving it over and over again. So it'll be kind of amusing if chopping down forests, planting grain,
sense.
extending an irrigation system is sort of done because you want to politically expand your control over the local peoples, rather than it being just the best means of sustaining the most people.
How would that work for political control? You're saying people become addicted to bread, and then you gotta give them.
I'm addicted to bread,
so they have to keep coming to you.
Exactly, and the very system of producing bread is centralized, at least in a desertified region. That requires irrigation to grow a lot of grain.
Yeah, I don't know how I feel about that theory, but I do have to say, if someone gives me tasty white bread, I will definitely overeat it afterwards. Be like, why did I eat so many rolls? Jesus.
Yeah, there's something almost compulsion-like about it. I don't necessarily think this theory is the theory of what happened, but I think we have to consider these alternate theories. Another example is brewing barley at scale, things such as the introduction of alcohol. These are then substances that we do know can be addictive. And there's some evidence near the Göbekli Tepe site and other sites in southeastern Turkey that, they were brewing beer in the Neolithic.
You mentioned that there's new evidence that there may have been a more advanced civilization, 20,000 years ago, something like that? You want to tell us about that?
Well, to be precise, I think we can infer that there were civilizations 20,000 years ago. Evidence exists of agriculture 20,000 years ago. Evidence of, I think, a different complex society that pushes aside the 10,000 year date is the site of Göbekli Tepe in southeastern Turkey. That site is currently dated to be 11,500 years old. Now, why does this matter? This matters because, again, the normal story of origin of society is the Ice Age ends, climate becomes predictable, we can engage in agriculture. After we have agriculture, we start doing things like monumental construction and settled permanent living. This site in Turkey has evidence of what is assumed to be a set of temple complexes, concentric circles built with these massive pillars, each weighing 10 to 20 tons. The current estimates are that the needed labor force to assemble such buildings was about 500 people. Now, we don't have evidence of agriculture from that particular site, but it is a very old site. It's 11,500 years old, much, much, much older than Stonehenge, much, much, much older than the pyramids. But then I have to ask you, how are those 500 laborers fed? Looking at the climatic data of the region, it was as dry then as it is today, and it's far away from a bountiful source of fishing. So if it's not rich wildlife, like say the North American plains once provided, if it's not, these sort of chestnut style forests, if it's not fishing, what exactly are the laborers eating, right? How are they being fed? How do the economics of their communities work? So I think it's indirect evidence of agriculture. And then if we flip it around, I think agriculture is then like also indirect evidence that somewhere in the world where we haven't yet dug probably, there are older permanent settlements. There are places where fully relying on agriculture likely was the correct choice even 20 or 30 or 40,000 years ago. Once you go past any sort of default null hypothesis that you had, right? When we had this null hypothesis of it all developed after the last ice age, your next best guess is not on the basis of just the finds. It is on the basis of, well, what's the new null hypothesis? Where should we dig? What's the new hypothesis of when did humans start behaving in this novel way, right? When we find beaver skeletons, we have no problem assuming that they built beaver dams. When we find human skeletons, we're much more reluctant to assume that they have an associated extended phenotype of a certain kind. And I think that's a little bit of a bias. That's a mistake, and it would be very fruitful to explore this further, partially because the most recent finds are the floor, not the ceiling of past achievement, right? We're getting a very, very attenuated sample from the past. But on the basis of seeing what human beings are, what kind of behaviors we have, which technologies travel together, we can infer more than what just the finds themselves show.
Presumably only a very small fraction of civilization development ever gets recorded in history. Is that right?
Yeah, the vast majority is lost. I mean, we know even with written sources, we have an interesting estimate. There's an estimate that of all the ancient Greek authors and Roman authors we know by name, for 94% of them, we have no complete works. We don't have fragments of their writing. These are people who are name dropped in the books and scrolls that we do have that are mentioned as authors, but we never found those books. So if written material that can be easily copied is attenuated in this way, I think we should really consider what are the odds that we're going to have preserved always the peak of human achievement. I think it's really unlikely.
So why should we care about whether history is 10,000 years old or 20,000 years old or longer? What are the kind of consequences of this?
I think one of the biggest consequences is that perhaps we have to reevaluate what Homo sapiens is. Now I have to say that, again, this is not something that's been proven, but it's a hypothesis worth exploring. The hypothesis being that maybe Homo sapiens has always been a gardener. Maybe we have always occasionally lived in villages. The consequences for any attempt at, say, an evolutionary psychology would be significant, right? It would suggest that, oh, perhaps we do have evolved behavioral adaptations to societies at even a scale that's larger than Dunbar's number. Another important one is we might come to understand, or we might see further evidence of something that I think is already established but neglected, which is the fragility of complex human societies. We know just from recorded history, that's the last 10,000 years, not counting any of these extra millennia, that we've had about, let's say 10 identifiable dark ages just in the Eurasian continent. Social collapses like the late Bronze Age collapse in Eastern Mediterranean around 1000 BC, or much earlier, the end of the Mohenjo-Daro-based Indus Valley civilization, which was the first civilization in India, or later examples that, they're much better known, such as the fall of the Roman Empire. This should be a warning for our own society, right? And I think the more data we have, the more complete our data set is of these civilizational collapses, the better we can understand the common threads behind them, if there are any, and the better we can prepare and prevent our own societal collapse, right? After all, we have grander aspirations than just to be another set of ruins for future archaeologists to study.
Well said.
Sad
So I
frog.
want to get into civilizational collapse with you. But before we do, you mentioned that this idea that agriculture might go back much
and it's
further,
MJ.
maybe town dwelling might go
suppose
back much further than
if
people
you're still
realize.
here.
This is a theory. We don't know for sure that it's true. What kind of probability would you put on it if you had to bet on this?
Oh, I'm very happy, in fact, to set a bet. I would put the odds that humans have lived in villages, at least occasionally, for a very long time, at 70 or 80%. And by a very long time, I mean many tens of thousands of years. I recently wrote an article titled Why Civilization is Older Than We Thought. And after reviewing all of this evidence, I conclude the article by saying that I'm happy to take a long bet with a qualified challenger. You know, what's a long bet? It's a bet that's resolved over a longer period of time. So the bet's terms are 20 years from today, we will know of at least one permanent settlement older than 20,000 years. And 20,000 years because that's comfortably on the other side of this ice age transition, right? That's usually referred to. It means that the old scientific paradigm is broken and that we are in a different paradigm of history. So I'm comfortable betting that we will find something within the next 20 years.
When was this ice age?
It depends on how exactly you date the end or the start of it, but there's a general broad consensus that the last glacial period occurred from the end of the Eemian to the end of the Younger Dryas. So the ice age is considered to have lasted from 115,000 years ago to about 11,700 years ago.
This would suggest, according to the bet you want to make, that there were towns and their
permanent settlements 20,000 years ago. Yeah, exactly.
Right, so that would be during the ice age, right?
Exactly, during the last ice age. And I think then that conclusively breaks this sort of old hypothesis, and the history books have to be rewritten. And people have to say, well, you know, humans started settling down in permanent settlements sometime during the last ice age. We're not sure when, maybe 100,000, maybe 50,000, maybe 20,000 years ago. Our best evidence is 20,000 years ago, right? It wasn't the climate shift that pushed us.
And the alternative, just to make sure I understand, is that what, humans were in bands, but they were roving bands, that they didn't have kind of permanent settlements?
Yes, the humans were in roving bands. These bands were small, let's say 50 people, maybe 100 people. They never settled permanently. That wasn't economically or socially sustainable. They never made use of agriculture or gardening because, you know, that requires you to stick around, right? It requires you to be in the sort of same range. So yeah, the alternative is that there were only Paleolithic cultures all around the world, rather than cultures that, in my opinion, reached a Neolithic level of technology.
Got it. Okay, so now going back to civilizational collapse, which is obviously really important when we think about our future. You know, as you said, we don't want to be one of these ruins that's eventually found by future people. What do you think we can learn from past civilization collapse about potential future civilization collapse? I know it's a broad question, but I'm interested to hear your thoughts.
First off, there are several interesting books that can be read on this, right? There's Tainter's book, The Collapse of Complex Societies. There's Jared Diamond's book on civilizational collapse, which focuses primarily on climactic causes. I think generally, I'm willing to say that societies dissolve mostly from within or from external conquest. Climate can be a stressor, climate can be a significant issue, but looking at fully developed societies, so not peripheries, right? Like whatever we think of, say, Vikings in Greenland, they are the periphery of Norse civilization. They're not sort of the core of it. They're not the center of that society. They're just this far-flung outpost. So them being pushed out by climate, the way Jared Diamond argues, well, okay, that's not really saying much about society as a whole. The same, I would say, actually applies to the Easter Island, which is this far-flung element of Polynesian civilization that's, you know, or complex society that's, of course, inherently fragmented. It's an island hopping culture. Whenever we looked at these examples, you know, if you go through history, I think you see sometimes frontiers being pushed back and forth by climate, but really, usually the society itself has ceased to be adaptive to novel circumstances, and that's the real cause. It's kind of like if I take a fall when I'm 20 and I break my hip, I'm very unlikely to die. If I take that same fall at 80 and break my hip, I'm actually in a lot of trouble, right? I might not recover. So that's how I would describe climactic effects. I think if a society is adaptive, vital, it will perhaps take a hit, but it will adapt to new climate conditions. It'll come to live with them. However, if the society is already in trouble, such as, say, the Mayan civilization was, right, then I could think climate could be a decisive blow. And I'm using here climate to be a stand-in for all sorts of other factors, right? Factors such as resource scarcity or other environmental shocks, such as plagues and so on. Mayan civilization, by the way, of course, ended long before or reached terminal decline long before the arrival of the Spanish and other Europeans from the Old World. It was, 12th, 13th century. It was already an area in the Yucatan Peninsula that the jungle had almost fully reclaimed. Even today, it took new techniques such as the use of LiDAR from planes to uncover the full extent of the jungle, right? LiDAR is basically laser radar. The laser beams can occasionally bounce through the canopy. That's why you can sort of take a picture of the landscape that strips away the vegetation. And there's some very interesting work done on that. And it showed that Mayan civilization's scale was greatly underestimated by an order of magnitude when it comes to the number of settlements, the likely number of cities, the population estimates, and all of that. So I think that we are going to find more surprises in the jungles of the world and the deserts of the world of this type. And I actually think that this kind of societal collapse and failure is probably inherent to a long-term attenuation and rigidification of institutions, where elites of a society tend to mostly lose any sort of caretaker or directing function and assume a mostly parasitic character, where they're sort of protecting their existing patronage networks or revenue streams or rents, right, in the economic sense of rent collection. So if you have elites vested in keeping things the same and you encounter something like a climactic shock, well, then your society might be in a lot of trouble, because if the elites are in favor of keeping everything the same in a given society, but the physical environment has changed, well, that might be resolved through the collapse of your society, not through adaptation.
Okay, so stepping back for a second, it sounds like you think there are two broad classes of reasons why civilizations fail. The first is from external threats, like they're just invaded by a neighbor or something like that. The second is sort of this internal rot. Am I right so far?
Yes. And of course, the external conquest can be facilitated by internal rot, though I believe that there are basically healthy societies that have been destroyed by external conquest, right? For example, I have no reason to believe that the Persian Empire that Alexander the Great conquered was decadent in any real sense. All the other indicators were very positive. They just were very unlucky to be fighting Alexander the Great.
Okay, so then if we think about this sort of internal rot that can happen, you're describing this as sort of having to do with institutions. Did you want to kind of give us the trajectory in the way that you view it of how institutions get started and then what happens to them that kind of makes them go sideways in a way that they kind of starts rotting a civilization from the inside?
Well, there are many perspectives on institutions. I take a somewhat functionalist view where, I tend to look at institutions and ask, what role is this playing in broader society? One way to think of societies and civilizations is that they are these interdependent ecosystems of institutions that are often, through the services they provide and the externalities, the positive externalities that they can never fully capture, even if they try to capture them, subsidizing all the other institutions in a cluster. Like, I think these societies are better thought of as forests, not as trees, right? So the death of any individual tree is not the death of a forest. The death of many of the trees to never regrow, well, I think that's the end of that particular civilization, even if you have later, different shrub growing or a different biome emerges in that area. So if you think of something like the university system, right, I would easily class universities as a basic institution type in our civilization. Universities are some of the longest lived organizations in Western civilization, especially. The University of Oxford predates the rise and fall of Aztec civilization, for example. It's a 1,000-year-old organization.
It's wild.
It is. And you might think, okay, Oxford, it's on an island, it's isolated, it's probably an exception. But the University of the Sorbonne in Paris is just as old or comparably old, or say universities like Bologna, they're also comparably old. And then, of course, we all know, Italy, France, these are places with frequent wars. So why do these universities persist? what are the longest lived institutions in the world is itself an interesting topic. Maybe we'll touch on it later. But to go back to answering your question, I think what happens is these institutions play a symbiotic role. They are often, say, places where knowledge of a particular kind is transmitted. They provide some kind of economic or political value. Over time, there are three factors. One of them is, situations change, right? Just because something was built, had an origin, was designed a certain way, doesn't mean that it's appropriate 500 or 600 years later. The second reason is you can have deep and profound succession failure, where, say, if you compare in classical civilization, the philosophers of the classical era with the philosophers of the Hellenistic era who had started dabbling in engineering and science, right? Archimedes is better thought of as a scientist. He's producing exact laws, running experiments, than just a philosopher, right? He's crossing this gap. And then you compare this with the Neoplatonic philosophy that exists during the decline of the Roman Empire, and you realize, wow, these people call themselves, say, Platonists, they call themselves philosophers, they call themselves engineers, and they're radically misinterpreting the texts that they have. They are producing stuff that's much less impressive, much lower quality. The scientific and engineering works that exist in the Roman Empire are greatly inferior to the ones that exist in Hellenistic Greece, right? If you go and read someone like Pliny, right, the correct way to think of him is that he is basically writing pop science in Latin for a Latin-speaking audience that's never read the original Greek works. Well, what happens when only the pop science is around, but not the original scientific works? When the original scientific works are lost, when the culture of science is lost, that's a pretty severe succession failure, a succession failure of knowledge. You can also have other problems, such as a succession failure when it comes to power, where you can have political crises that sort of break down a society more and more because the central authority fails. The new set of authorities that emerge have smaller scale, therefore have worse economies of scale. Those go on to fight each other more and more and more. And that would, say, be the civilizational crisis we saw in China after the end of the late Zhao dynasty, with the Warring States period emerging from it. And that's also a different way in which these societies can sort of self-cannibalize. So again, the first one is just changing circumstances. The second one is this failure of knowledge. And the last one is this sort of profound and fractal failure of political coordination.
Can you elaborate on the political coordination one? I'm not sure I understood that.
Right. It's basically where the conditions of political crises are no longer a passing crisis, but become a permanent political crisis. I could give the Egyptian civilization example, where Egyptian civilization underwent several transitions from the Old Kingdom to the Middle Kingdom to the New Kingdom. Sometimes these were driven by foreign invasions, and other times it was this almost like fractal aspect of civil war, where you basically have the replacement of central power with really, really fragile local power that's just as tyrannical, that's just as extractive, with eventually just roving bands of people. We saw some of this also in Mesopotamia, where during the late Bronze Age collapse, what used to be these very developed cities eventually became empires. The empires sort of start crumbling in eternal warfare, and it's driven all the way to the abandonment of agriculture. Large parts of Mesopotamia are no longer worked as fields, but become pastures for essentially nomadic people, nomadic herders. And these herders, they still claim amazing titles like the King of Ur, but the city walls, they're crumbling, they're grazing their sheep among the ruins. So it's sort of this endemic warfare, right? Fractal, endemic, unterminating warfare that's driving down economies of scale rather than driving them up.
Got it. So if we reverse these criteria for a second and think about what makes a civilization succeed over a really long time, it sounds like, one, you need adaptability. Like as the world changes, the civilization has to change to that changing world. Two, it sounds like you need a way of maintaining quality so that you don't just get a degradation, where an institution doesn't just become a worse version of itself, every 20 or 50 years. You need a sort of succession planning. And then the third one is, it sounds like you have to have some way of preventing the society from just falling into extreme polarization where it becomes just zero-sum conflicts all over the place. Does that seem like a right way to think about it?
I think so. The difficulty is keeping these three in a balance. Easily overshoot on, say, trying to provide peace and stability by setting up a sort of central authority that resolves all political disputes, and in the process end up killing adaptability, right? A big factor of adaptability is middle powers doing what, high power, central power cannot. In a way, possibly Roman conquests are to be as politically useful as they were for the Roman Republic, might have actually been the cause of intellectual degradation. When Rome conquers the city-states, but more importantly also these Hellenistic states like Ptolemaic Egypt, right, that are supporting efforts such as the Library of Alexandria, and the Romans themselves no longer support these efforts or no longer know how to tell the good philosopher from the popularizer, well, that leads to a degradation of knowledge, even if it stops, what otherwise would have been a very chaotic and war-torn region. But it was a war-torn region that was also growing economically. There's lots of evidence of economic growth there. So I think it's a difficult balance to strike. When it comes to knowledge succession, I think it's not just succession planning, it's also a matter of figuring out, well, how do you recognize when someone has the knowledge? In China, almost every single dynastic cycle throughout its history kind of reboots the civil service and comes up with a completely new civil service exam. It's not because the previous civil service exam was flawed or wasn't designed quite right. It was basically that over decades and centuries, people, when they were trying to enter bureaucratic work, would study for the test rather than to try to get the generativity and knowledge that the test used to be an imperfect correlation for. So essentially, Goodhart's law, for example, is a really significant barrier to our attempts to bureaucratically measure and replace human talent. And I would argue that it's Goodhart's law, which is that as soon as some kind of social measure becomes a target, it ceases to be a good measure. I think that was actually this fundamental foe that each Chinese dynasty had to struggle with. You kind of had to set up a new test so people wouldn't guess the passwords, wouldn't guess the fake version of the knowledge, right? And would actually end up being competent civil administrators and competent scholars and all of that.
In your view, should we reboot the SAT and ACT in the US as entrance exams to colleges every 20 years or something like that?
I think it might be very useful. I haven't studied those in particular closely enough. And I know that there is a competing hypothesis that of G, that the hypothesis being this sort of like general factor of intelligence, and that these tests actually, correlate well with it and stuff like IQ and all of that. I would say that we would do well to completely reboot university admissions every 20 or 30 years. Because I note that, in current America, it's the sort of intangibles that people are prepping in their application as much as it is the prepping for the test itself. And I do think, for what it's worth, with the caveat that I have not studied them that closely, I do think these tests can be prepped for. But even more important than that, I think, when someone comes in with a CV and they created a whole new nonprofit during high school, and the nonprofit was in a fashionable cause, and they have beautiful photos of all the work they did in high school on that nonprofit, how staged is this? And in fact, the answer is, yeah, it's fairly typical for very staged high school experiences where people are building up essentially a fake resume to hand to the university administrators and the admissions officers, and they have to write a good story about it, which, okay, that's a real test of skill. But the choreographed high school experience, well, that's just a reflection of a certain kind of class privilege. That's not a reflection of intelligence at all.
So it seems to me that one of the most important questions that we could ask about this framework for why civilizations fail is, why is our civilization going to fail, right? So let's take a moment to kind of do an exercise, and let's imagine that the United States fails at some point in the future. What is your best prediction about which of these elements lead it to fail, and sort of what's your kind of most predictive story on that?
I think it's always hard to imagine a civilizational failure from the inside. Historically speaking, Roman sources and poets, they never really say, oh, our civilization is in decline. They say everything is great. Late Zhao civilization, in China, late Zhao civilization, they are quite aware of their own decline, and possibly that's why they managed to reverse it, and why Chinese civilization experiences another golden age fairly quickly after the Warring States period, right? The Han era especially, and the Han hegemony. For our own society, I think each civilization is, again, it's a different ecosystem. It's a different set of institutions. I think there are many deep similarities between our cities and the cities of antiquity, but there are also massive, massive differences in how we organize production. To predict a fall of a society or how that might look, you need a hypothesis as to what are the core social technologies of that society. What are the core principles of organization? What are the core institutions of it? I think for our own current society, the best guess is probably industry. I think the Industrial Revolution looks fairly interesting, might be historically unique, might have some mild predecessors in Hellenistic era states. But if we take the Industrial Revolution and the new system of production that emerged in it to be the core of our society, I think what we would see is a failure where over time we lose the capacity to organize material production. And at no step can we acknowledge that this is what is happening. When deindustrialized, the factories moved to China. What if in fact China will eventually have to move the factories elsewhere? The positive version of this is that it's no longer their comparative advantage, right? They're going to outsource to Africa, to India, and those places in turn are going to industrialize. Well, okay, let's say they do that. But what if the negative version of the story is true? What if there are difficult to measure types of social capital, such as public truth speaking, work ethic, high social trust between, small teams of people, that in turn enable things such as collaboration on the factory floor, accurate reporting of profits and losses, accurate logical understanding of how to organize material production and improve your product? It could actually be that we are exhausting the social capital needed to maintain industry. In that case, maybe the Industrial Revolution goes into a post-industrial society, not because we transcended industry or because we offshored it. After all, it's a finite planet. Eventually we'll run out of shores. At that point, prices might begin to rise, products might become worse. As soon as products are worse and prices are rising, globalization ceases to have good returns. Once globalization ceases to have good returns, it's not like a static system. It was one predicated on growth. You might see it shrinking. As globalization shrinks, recedes, the beautiful economies of scale that allows us to build all of the world's CPUs on a tiny island like Taiwan cease to be so beautiful, right? The economies of scale break down, and you have to perhaps revert to factories serving more local markets that make slightly worse chips. I don't know how far this could unwind, but if this hypothesis is true, followed by also this assumption about the social capital hypothesis, that in fact we don't know how to have disciplined, well-organized workers in Western societies anymore, and that in a few decades China won't either, and a few decades after that Africa won't either, and that we won't know how to reward excellent engineering and improvement, or even accurately materially give it its due and reinvest. If all of that is the case, then I think our society doesn't recede completely back into the dark ages. I do think we fail to complete the information revolution. I think we start rolling it back. All of the beautiful AI and machine learning innovations that we're seeing, these are all predicated on massive, massive amounts of compute. So if the price of compute goes up, these innovations go away, right? They have to be radically downscaled. Algorithmic progress and so on has been much slower than just progress in computation. I don't think we quite lose cars, but we might lose everyone having a car. Cars might be rare, and this in fact could be even rationalized in public discourse. Every year your washing machine would be a bit worse. Every year your car would be a bit worse. It would be hard to find replacement parts. You would have to be relatively scrappy and improvised. Buildings would look like they need a fresh coat of paint. Plane tickets would be, something that, you can't really afford anymore. This imperceptible slow decline in living standards, together with the machines becoming shoddier, I think it would stabilize at sort of like kind of living standard comparable to the 1930s, except I think, for example, we would probably keep a cell phone network, though maybe our phones wouldn't be quite as smart. And we would probably keep something like the internet, though maybe only 5% or 10% of the population could log on. So I do think that there is some amount of progress that isn't wiped out by such a fall, by such a intellectual and economic dark age. That is absent external shocks, right? The only way that I think something like currently ongoing and human-driven climate change could prove to be truly disastrous is if we experience such a dark age just as there are these massive, massive disasters unfolding, or massive deep climactic transitions, such as transition to a new ice age. In that case, it could get much worse. It might go all the way back to agricultural society.
I imagine that many people listening would be surprised about this prediction because we have such a strong sense that things move forward and not backwards. The technology progresses and doesn't regress. So I wanted you to just talk a little bit about that, and also what it would actually look like to lose these capacities. Because, what more specifically would be lost? Why couldn't you just set people up in the same way that they used to be set up? What would actually be gone now?
Yeah, I mean, we are used to everything getting better and nothing getting worse because that's the trajectory our current civilization is on. We can be optimistic and hope that it's an inevitable law of history for the future. I'm here not commenting about progress over all of human history, right? I'm just commenting on progress in a particular human society. You can easily imagine a thesis where, progress is true, but there are setbacks. And again, I think the history of the world really does demonstrate this, right? Population did go down after the end of civilization in classical antiquity. Our best population estimates for the population of the Roman Empire are 60 to about 250 million people. That's a population size that is quite comparable to modern states. You had, 7-story apartment buildings in ancient Rome and so on. You had engineers such as Heron of Alexandria building steam engines and so on. If the belief is that, oh yes, our technology is so much better, it's so much more advanced that it's sort of impossible for us to lose it, I would counter this by saying this much more advanced technology is much more complex and has much greater material demands than, say, ancient Roman technology did. Hellenistic society didn't need to conquer the planet and open all of the oceans to trade routes in order to sustain its economies of scale, right? It only needed to, say, secure the Mediterranean. Modern society really does need it, right? Like the only way, the real complexity of a CPU or a phone or a car isn't the car, it's not the CPU, it's not the phone, it's the factory that built the phone. I guarantee you that if you look at your car, the factory that built your car has 100 machines, each at least as complex and difficult to make as the car itself. And if you look at those, right, each of those machines is probably made in a factory. But when you look at the factory making the tools that build our tools, it stops being so big. It starts being this weird workshop in Germany or Japan making very specialized equipment, maybe putting out a small volume, maybe like 50 or 60 machines a year, or just a small amount of these very precise, very high quality tools, such as machine tools. So if you start hitting the basis of our society, let's for the sake of argument say that is mass production, where production goes down, it becomes more expensive to make each individual car. And then it becomes more expensive to make each individual robot that's making the car. And then it becomes et cetera, all the way back to that little weird workshop in Germany or Japan. At the same time, all of the existing power centers remain in their place. Medical debt continues to go up. Education continues to eat up more and more. If you have a society that's stagnant, that's not growing, or even is actually its economy is slowly shrinking, and instead of growing, it's shrinking, all the zero-sum races of things such as, oh, I have to stay in the middle class, so it's okay for me to go into debt because as long as my kid makes it to Stanford, they'll be able to get an okay job, and then one day they'll be able to afford a house, and maybe I'll have grandkids that way, or at least grandkids that are not downwardly mobile. All of those dynamics become so much more brutal and worse. At no point does, say, a university degree become cheaper in a world where cars have become rarer or more expensive, or where cell phones cease to be an everyday good. At no point do you have power centers just step aside and cease rent extraction. So at the most theoretical level, this would be rent extraction exceeds economic growth. All that would be needed for that is for economic growth to stall, because this sort of rent extraction, this sort of zero-sum type competition is in fact spreading, is in fact metastasizing. It's just been outgrown by industry every step of the way for many, many decades, if not many centuries. And, you know, I feel these are arguments about plausibility. They're not necessarily arguments about likelihood, though I am trying to pick the most evocative examples I can. And really, once we think about something like, you know, current civilization, why in the world do we think that we've reached escape velocity, sort of metaphorical escape velocity, right? Where we shoot off into space and we grasp infinity, rather than we are just another society, just as all the other societies were, and we operate at a bigger scale. But does that really mean our curve is going to end up looking that different? Every single past civilization has eventually failed and has experienced regression of technology, of population, of wealth. I think it's an extraordinary argument that we are different. So I feel I've yet to hear that extraordinary argument.
So when you talked about certain capacities being lost, it sounded to me like they were social capacities that could be lost. And then later you mentioned sort of what I thought of as a sort of a different idea, that there's these two competing forces. One is forces that sort of extract from other people, and the other is a sort of growth force where, like, you know, productivity increases. And if you have the extraction force of, like, basically, you know, let's say middlemen, like, that aren't adding any value, but could actually suck away money from people, or other extractive forces, and if those exceed the growth force, then you actually start getting decline. So those seem to me like two separate ideas, losing these kind of the social technology and then that separate thing about extraction. Or are you viewing those as the same thing?
I agree that they are separate, but they are mechanically connected. To say a little bit more about this, social technology being things such as law, organized religions, basically elements of culture. But I prefer to use the term social technology because I think we kind of today tend to think of culture. It's just, you know, it's a different skin you put on the same sort of mechanical structure, right? We assume it's just it's a different flavor, right? It's sort of like, oh yeah, culture. That's like, you know, the difference between different cultures is like the difference between vanilla and chocolate and strawberry ice cream. It's kind of important, but kind of irrelevant. It's all ice cream. It has the same caloric content. It delights different people in different ways. Meanwhile, social technology is like, no, actually, there is social machinery in operation, and different societies have different social machinery running. Not bad, not worse, often difficult to evaluate from within the value system of any one given society. And I think the evidence is really strong there, that there exist different ways of doing things, different modes of social organization, different types of organizations. I don't have much tolerance for the person that says that, say, the law you might have experienced in ancient Athens is the same as the law and legal enforcement mechanisms you might have experienced in medieval London is the same as the legal enforcement mechanisms you're going to experience in modern day London. And it's not just technology. Think about something like policing, right? The existence of a police force is a feature of modern London, not of medieval London and not of ancient Athens, right? So this is like a social organization issue, not just a technology issue, right? It's not just the CCT, the closed circuit cameras all over London that make law different in modern London than medieval London or ancient Athens or Rome or whatever. So really, first, I just wanted to clarify a little bit what I mean by social technology. But now to answer how the two are related, if you have a social technology of a norm of public truth speaking, where you are embarrassed, lose face, and are shunned from economic opportunities for saying untrue things or things that are not backed up. And then this is replaced by a norm where you are perhaps even actively rewarded for saying untrue things that are, however, tactically expedient with economic and political rewards. Well, it was intense competition, kind of zero-sum competition, that made it so that it was more profitable to be less than truthful, to be a propagandist, to be a salesman at all costs. But it resulted in a change of social technology. So I sort of feel this growth between an extractive and a productive force, this ratio between the two. I have this piece of writing called Empire Theory where I dive into this, and I propose that we can think of, in a simplified way, a 2x2 matrix of expanding and declining and centralized or decentralized. You might have an expanding, centralized society where it's the center of society and the central powers that are engaged in the forces of production, or you might have a decentralized, expanding society where it's the periphery that's growing and the center is kind of stagnant, or you might have a centralized, declining society where the center of society is drawing in all the resources into itself in a very vampiric, parasitic way. It's easy to argue that the late Roman Empire was of this type, and so on, right? The different regimes of growth and extraction result in a different landscape of applicable, viable social technologies. And after a social technology leaves living memory, it is very difficult to reconstruct. People in medieval Europe saw no fundamental break between their society and the society of antiquity. That's why, when they refer to people by the title of dukes, right, a hereditary feudal title, it came from an ancient Roman appointed title, dux, right, a kind of administrator. You can have something still call itself a republic, call itself a monarchy, call itself the Persians or whatever, or the Egyptians, even if all the practices have changed. So once you no longer have that living memory of how this social norm operated, and you can never fully put this into words, right? This is very tacit knowledge. It's people's behavior. A written description will be less than helpful. At best, you can use it as inspiration to try to re-engineer the past, but unless you have mentors or people who are skilled at this mode of behavior, that's going to be very difficult to reconstruct. So I claim that the social technology just will reliably be lost. So I think that if you have extractive force in a society overpower force of growth, you will reliably start losing certain very pro-social social technologies. They might be replaced by other social technologies, right? You might have a society that's in a very extractive orientation. It might really perfect, for example, some aspects of propaganda or some aspects of political control or some aspects of warfare and so on. It's just on net. I think they're going to start losing social tech.
I guess the idea would be with loss of certain social technology, that could actually have implications like losing the skill to make the machines that make the machines that make cars or something like that. And so with erosion of that social tech, you could have erosion of like the ability to actually build useful technology. Is that the idea?
Well, yes, I can even make it more specific than that. It might be perhaps that there is not a single good engineering school left in all of Canada, or not a single good engineering school in all of Europe or America or Russia, and that you find it really difficult to hire a good engineer. Also, when you try to hire a good engineer, you're not quite sure how to tell who is a good engineer and who's a slightly worse engineer. So when you hire and you start making products, to your surprise, you realize that the error rate is unacceptably high and that the profit you're making isn't as high as you would expect. Again, I really want to hammer home that this isn't purely hypothetical. We in fact saw a version of this during the late decline and eventual collapse of the Soviet Union. You had a decline in technical capacity. You had also, to some extent, a decline in living standards, a massive drop in fertility, a massive drop in expected lifespan. Now, of course, the collapse of the Soviet Union was not a full civilizational collapse, but I do think you would probably agree with me that it was a kind of like a catastrophic deindustrialization. And of course, it was an oppressive society, et cetera, et cetera. Maybe it was better to end that experiment, but it was a deindustrialization. It was a de-skilling. The few remaining skilled people, left for the United States in Western Europe. And today, Russia struggles to reindustrialize. I mean, I guarantee you that, Putin has probably done his very best to try to reindustrialize Russia over the last 20 years and has completely failed. And one story is that, okay, Russia was just economically outcompeted. Another story is the Russia of today is not the Russia that industrialized, right? And the social norms are too different from those that would enable industrialization.
When you mentioned kind of this particular theory of how American civilization could collapse, I was a little bit surprised because I expected you to focus more on institutional decay. Like our institutions were built for specific purposes and then the world changed and they didn't keep up, or they became sort of parodies of themselves over time increasingly, where maybe the people that founded them really were focused on solving a certain problem and then their successors were a little bit less focused and, 3 generations out,
they've completely lost the plot. Yeah,
exactly. Do you have thoughts around that form of decay and how that could affect America?
I think that form of decay is it's obvious, but from any particular institution decaying, it's hard to establish that the society as a whole is in decline. I think that form of institutional decay can eventually then result in all of these other economic and technological problems that I described. I hope it's obvious that, if you had institutional decay in, say, the Federal Reserve or the University of Harvard or, the US federal government, some of its branches, such as, for example, imagine a DARPA that's much worse at its job. What's the compounding loss to yearly GDP growth? So again, that's sort of the other side. That's the more institutional perspective. The only reason I focused earlier on mass production is because I was running with the hypothesis that industrial civilization is a unique phenomena. But the more general theory of institutional failure is, again, a theory where the institutions become extractive. They no longer fulfill their purpose. They at best maintain themselves in their resource distribution. They no longer deploy these resources well. They no longer attract or cultivate the right talent, and they are not replaced by other institutions. The sort of perspective I would give is that, there are organizations that prevent us from making better, much more functional organizations. If you imagine the set of contractors that NASA was working with for the past few decades, it seems very obvious that these contractors were actually an impediment to aerospace progress rather than an asset. And it took extraordinary efforts for the creation of something like SpaceX. Why was that an extraordinary effort? The engineers were lying around. Well, yes, the engineers were lying around. They might want to build some things. They might even want to build useful vehicles, much cheaper rockets. But who exactly was going to be the client for SpaceX? Elon actually had to maneuver the company and, his successors as well. They've had to maneuver SpaceX so that it was capable of winning the right contracts that would make production of rockets like the Falcon 9 and later ones like Starship worthwhile. They would make them worth the investment. So old institutions can crowd out new institutions even when they cease to be as functional. And then, of course, sometimes extraordinary teams or individuals find ways to circumvent those dying old institutions, but other times they don't, right? And the society really rigidifies in a profound way.
Yeah, that makes sense. Yeah, I imagine a situation where if universities got much worse and they were still producing sort of the people in charge at a lot of the other institutions, that could have kind of a follow-on effect, right? Where now you're getting people coming out of the universities that are not qualified to run these other institutions. Or another example might be if newspapers and the media continue to get worse and worse, then eventually it becomes harder and harder for everyone to sort of figure out what's really going on and what's just political spin. And you could see that sort of exacerbating many of these other problems simultaneously.
Right. You could see, in fact, over time, a decay and poisoning of the epistemic commons, right? Because we do, I think, rely always when it comes to truth seeking on other people, right? We have to rely on them because there's just too much stuff to figure out. And you have to trust your ability to evaluate experts directly, or you trust whatever system that exists, such as a university, that evaluates experts for you. Now, the fun fact about institutions is nothing stops them from lying to you, One of my favorite anecdotes when growing up was when I asked my dad about the transition from communism to capitalism, because this was super notable to me. I grew up in the 1990s. And he said, he sometimes he wouldn't be as eloquent as I am. Let's be polite and call me eloquent rather than verbose. And all he said was, Samo, no one asked me to redo my economics degree.
So he's still,
isn't that deeply important somehow? If it's just about the content he learned, all of the socialist economics should have been falsified, right? It should have been, the Marxist stuff should have been replaced by, I don't know, not Ayn Rand, but a Hayek or Keynes or whatever. No one asked him to redo his economics degree. He just continued, in his role as a CFO or whatever. And
that's what I
often think back on that and sort of
okay, where's the cargo
we
drop?
trust this credentialing system, and we trust it even after the falsification of the core theory the credentialing system was measuring happened.
Yeah, it seems like in general, any corruption of a credentialing system that really is trusted by people has these very severe knock-on effects. Once the credential can no longer be trusted, but people don't realize it can't be trusted, now you just have misinformation being spread. And then it's like, well, how do you go back from there, right? Once the credential doesn't mean what it used to, of course, the people doing the credentialing are not going to go, be like, oh, yeah, you should stop listening to us, right? They're going to find ways to justify why you should still listen to them.
Exactly. I mean, at the end of the day, one of the reasons The word authority in modern English has a mild negative, almost pejorative sting to it, is because Protestant critiques of the Catholic Church in the 16th, 17th, and 18th century focused on its claim of authority over questions of salvation, right? So there are all these big tracts like decrying the supposed authority of the church and so on. Kind of over time, the term authority acquired this negative connotation where originally kind of all it means, this kind of auctoritas, is that you have the relevant knowledge and people should probably listen to the person with the relevant knowledge. It's an easy claim to make. It's difficult to substantiate, though. It's harder to substantiate.
So we've talked about ways institutions can go wrong. Do you want to tell us a bit about functional institutions and what they do differently?
Yes, I mean, there's no single unifying theme to functional institutions. I would broadly say that they overproduce radically. They're not difficult to spot, right? A functional institution will be this organization that almost on any metric you choose radically outperforms, given its resource base, let's say, an organization nominally of the same type. So this happens if you look at religions, organized religions, such as churches. There's very clearly, there's one church that's kind of the biggest. It's like the Catholic Church. Now you might say, so what's the point of organized religion? I'm not going to comment on that. Functionality here is a little bit immoral. It's just noting that there exist these really massive, profound outlier organizations. The same could be done for states. The same could be done for companies. In fact, it's routinely done for companies, right? People note that in their heyday, there are some firms that seem to just have a golden touch, just have this economic magic to them. And it persists sometimes for years, for decades, for the lifetime of a founder. And then generationally, they usually are some sort of flaws, some sort of problems with it. So again, one feature of the institution is it's radically overproducing its peers, outproducing its peers on something important, right? Either number of believers, amount of territory captured, widgets produced, whatever. The second sort of identifiable sign of it, this one I think is probably also mechanically relevant. So it's not just a symptom. It might be, in fact, like a cause for the functionality. I think the founder plays a very significant role. Now, the founder doesn't necessarily need to have dictatorial control. Maybe they set up a very different system of discussion, debate, and work where they only hold a tiny portion of that power. But initially, they still were the one that that created the system, that put it into motion. Again, a comparison here could be made if we're going to reference political theory to say America's founding fathers. They had a lot of political power in early colonial America, but they set up a system where none of them individually necessarily held all that power. Still, it's a fact that they did set up that system. The Constitutional Convention was 300 of America's most powerful and rich people gathering together without public oversight to determine what the next government of America should be. I really think that the Constitutional Convention at that moment was the designer, right? A collective designer, if not an individual one. And of course, it was a unique historic circumstance. Still, if the designers are still present, usually the maintenance of a system goes well. If a designer is not present, if that founder cohort or founder is not present, then maybe you have solved the succession problem successfully and you correctly identify new individuals who have what it takes, or maybe you didn't, right? So basically, when founders are present, I think things go better. When founders go away, maybe it's okay, maybe it's not. It's like lower probability. Another feature of a functional institution, I think, is there is internal differentiation where, in fact, people develop very deep skills and they exist in social symbiosis with the other individuals. So people's roles are perhaps very different, but they're not necessarily like that status differentiated, if that makes sense. They sort of know what to expect from each other. It's almost like these sort of Jungian archetypes, or to put a more modern frame on it, it's like a superhero team, right? It's all, kids on the schoolyard will always debate which superhero is the best and could beat all the other ones. And the point really isn't about that. Like, the team, each of them is very distinct, Hulk, Thor, whatever, Spider-Man. They're not, however, competing. They're not fighting. They're not like reproducing excess capacity. They're each doing something quite different. So let's call this functional specialization, right? Functional specialization. which can very naturally lead to hierarchies, but doesn't necessarily lead to hierarchies.
So what's a good example of that in a successful institution?
I think that there are examples from the history of engineering and the history of war, but since I've talked so much about the industrial process, let's maybe talk about the Prussian general staff system, right? In the Prussian general staff system, a general was not the person that concocted the entire strategy of a battle. Rather, it worked much more similar to take a fictional example, the bridge of the Enterprise in Star Trek. The Prussian general would have a particular question, something about the battlefield, something about the contingencies of the battle. He would consult staff officers who were in charge of planning for these contingencies, ask what the situation is, and sort of worked as this type of extended brain, right? There's this team of people. They exist in this super hierarchical environment where all of military culture is about following orders and so on. Yet they kept it as a necessary prerequisite of work there that, if the general picks the wrong plan, you as a staff officer could still register and write down your protestation of this choice, right? You could object to the choice that was made. You couldn't overturn it. However, later on, if the course of the battle revealed you were right, well, that was very important. And almost as a matter of habit, the Prussian generals did defer to the decision of the sort of staff officers.
So was there any other properties of functional institutions you wanted to mention, or those three cover it?
Yeah, I think one of the more important ones might be also that functional institutions tend to be somewhat unique. I think that they don't necessarily engage in that close an imitation or mirroring of other organizations. They tend to be, for lack of a better term, intellectually sovereign. They feel qualified and justified to think about their area of human activity and don't really seek out external authorities or dependencies. So that may be one more important feature.
So do you want to just give us a few examples of like kind of classic functional institutions, just so people can have something in mind when they think about this?
I think that for all its flaws, 1960s NASA is actually a great example. It's a very mission-oriented organization. It achieves remarkable feats. Another example is the British Royal Society, which I think was absolutely vital to the creation of scientific culture. And I think it probably stayed functional for most of its history. I think that plausibly after the 1900s, or maybe as early as the 1850s, I think it falls out of functionality. But before that, I think it has a good 200-year run where it is consistently connecting scientists and thinkers around the world, not just in Britain itself. Another example that's, I think, a political example, right, of functionality, I think would be the Hellenistic states that were created after Alexander the Great's conquests. I think that, say, the government of Ptolemaic Egypt was an incredibly functional institution where it supported all the classical functions of a state, right, such as defense and, in Egypt's case, public irrigation, but uniquely also managed to support a healthy state-funded scientific enterprise. This being the Great Library of Alexandria, the Museon, was more than just a library. It was also a gathering of philosophers and engineers and scholars. These were all paid by the crown. Another example that's, I think, contemporary of a functional institution is, I would say, DARPA is relatively functional, and it's of the American defense apparatus is probably, let's say, the best at facilitating the development of breakthrough technology. It could perhaps be argued that it used to be more functional, that up close it doesn't work that well, but by the standard of functional institutions, it outperforms its competitors.
So you have this idea you write about sometimes, which is great founder theory. Do you want to talk about how that connects to functional institutions and then tell us more about how great founder theory works?
Yes. I tend to have like a very founder-oriented perspective. This doesn't necessarily mean that a great founder is just a normal founder who happens to be exceptional, right? Great founder theory is, after all, a theory of history. It's a theory of civilizational development. The core thesis is that social technologies are actually more similar to material technologies than we might assume. They have an inventor, an implementer, a popularizer, right? Someone that brings it to society. And I think that when you look at the broad course of human history, it's these social technologies ultimately that end up facilitating or getting in the way of the development of material technology. So social technologies have creators, social technologies seem to me to be a significant bottlenecks and gatekeepers, at least, of which material technologies come to be. Therefore, I sort of believe that it is this particular kind of deep social reformer that ends up being the most important figure in history. So a random general great founder theory differs from just a normal great man theory of history in that it focuses on these institution creators who produce new, unique, and innovative institutions. So a great founder would not just be a successful general, right? Most generals would not be great founders at all, no matter how important the battles they won. So no one Patton, right? No one Marshal Zhukov, and so on. However, Charlemagne specifically, who happens to be a conqueror, but also happens to be a deep social reformer of law and education, and most importantly, setting up the feudal system as is understood later, could be seen as a great founder, can be argued as a great founder, and I think is likely, relatively likely, that he defines this core of Western civilization around which later other institutions are built in parallel. A different example from Chinese civilization, not a social reformer, would be Confucius, right? Where I think Confucius successfully created a school of thought where he himself failed to execute the plan. Confucius's plan was that you're going to figure out how to cultivate human virtues, how to cultivate human capital. You're going to gather together all the thinkers you can find in China, and then you're going to go advise the prince of a particular small warring state in China implement these social reforms. That never worked out for him. He was always politically outmaneuvered. However, his successors, who were trained in the same school of thought, came to be very influential advisors to the later emperors of China, and in fact have reshaped Chinese civilization many times over, right? Many times over, the Confucian project after the end of the old dynasty was taken up again once more. So Confucius is a very strong candidate for a great founder. In, say, Egyptian civilization, I actually think that a particular architect and statesman, Imhotep, might actually be the best candidate, a better candidate than some of the other ones. And then when we start viewing history that's more recent, right, more recent history, it becomes trickier, partially because we don't yet know the score, right? We don't necessarily know which innovations are going to last and which are not. If we were speaking in 1970, I might decide to be provocative and call Marx a great founder of a new civilization. In fact, the list of the top 10 most influential human beings in world history made in about, 1976, I think, listed Muhammad first, Jesus second, and Marx third, and only then started talking about people like Napoleon, right? I don't think anyone making such a list today would put Marx up there with, Jesus and Muhammad, but at the time it looked pretty much like a new type of civilization was created, a Marxist-based civilization, and it might endure for many hundreds of years. It might redefine Russia and China. And honestly, maybe if the Chinese system continues to exist, continues to thrive, maybe in 200 or 300 years, it'll be considered that Mao or Deng were great founders of a new, very different kind of Chinese civilization, one not focused on Confucianism, not focused on the emperor, but rather focused on this materialistic theory of history.
So would you say great founder theory is kind of a refinement of great man theory? Because great man theory points to these specific people that had, sort of undue influence, like these great generals or presidents or whatever. But great founder theory, you're going one step further and saying, no, it's not enough to be in a position of power. You have to actually create a sort of new type of society or a new type of social technology that then kind of spreads widely.
Exactly. And it's not the case that you're engineering the full future course of a civilization, right? Psychohistory is not real, but it is the case that you have to fully implement a deeply transformative social technology of this type. And I think that it's not necessarily, even though the theory is called great founder theory, I think that very small groups of people could be doing this collectively as well. I do believe in, Scenius, the genius of scenes. I think something of that type is responsible for, say, the flourishing of Renaissance Italy. But essentially, I do think it has to be relatively small. It's sort of like these cultural changes happen too quickly and too completely, where the working prototype emerges too fast for it to be this slower process of, say, cultural evolution or this mimetic selection and so on. you have these really deep radical transformations like the spread of Islam, right, where Muhammad batches together a whole new system of law, a whole new system of emotional regulation, all of this stuff, right? And of course, if one's a believer, you say that, and that's evidence that he was divinely inspired, because there's no way a mere human being could do that. My theory is, at least that sometimes, yes, human beings can do some of that. And of course, they're very much outliers, and they aren't unstoppable. It's somewhat down to chance. And you might say, oh, actually, if history is saturated with this, then these great founders don't matter. They're inevitable. And I'm going to say, no, actually, they're not. One sort of economics framing of this might be is that I would say that great founders are radically undersupplied. You only have these individuals occur in the right place and time to do what they're doing once every few centuries, once every few decades. It's not the case that everything that can be done has been done. It's not the case that if, Charlemagne was counterfactually killed and so on, the Frankish state would end up becoming this kind of feudal society that it was. It's not the case that, if we had eliminated Confucius, Chinese civilization would have gone on the same course and so on. These are really idiosyncratic and unique individuals. At the end of the day, of course, these individuals are still who they are because of their environment, but they're not a necessary product of their environment. They're a very rare event.
Would you say that there are examples of this in science, or these tend to be more around things like religion?
I would say that they definitely exist in science, because I consider science to be a whole space and deep well of its own set of social technologies. And I actually think that the study of science would do very well to closely examine what it is that is unique about scientific culture, right? The self-perception of scientists is valuable, but not necessarily accurate. At the end of the day, we don't ask a bird to teach us aerodynamics, even though we don't question the bird's expertise at flying. So, scientists could easily be practicing science and be quite wrong about science. In fact, you can tell, because if you ask different scientists about how science works, they tend to disagree, yet their unstated, non-verbalized intuitions as to who to trust, who not to trust, who is insightful, who is not insightful, they actually tend to agree on those. They tend to agree who they respect, even though they disagree on their explicated principles of science. Now, if you're asking me who the founder of modern science is, or who among the founders of modern science is, it's almost too difficult a question. It is something that I think would require a deep dive in its own right. I could say make some arguments as to who I think is the founder of particular schools of thought, but then how civilizationally transformative are those schools of thought. I do think that whoever you choose to attribute the creation of the Royal Society to, and there is some ambiguity there, has a very strong claim to the title of the great founder of science.
Can you have a small group be the great founder, where they're sort of ripping off of each other in a way that creates this new social tech?
Yes, I think that there are some of this happening with Alexander the Great,
it's
where
just
of course
frickin'
Alexander
Voyager.
the Great's tutor is Aristotle, and most of the key decisions are taken in partnership with his other key generals. And we can tell that it's not just Alexander the Great himself, because once his successors inherit various parts of the empire, note his successor isn't his son, right? There's this vicious set of civil wars that happen. You have people like, Ptolemy or Seleucus who are competing very strongly. If it was just Alexander, these generals would be overthrown by native elites. In Egypt, for example, the priesthood is still there, the powerful priesthood. Or in the Persian example, many of the Persian nobles are still alive. Or in the example of various Greek city-states, the city elites, be they the wealthy citizens or priests or local commanders, they're still around. None of them actually manages to change the political system and the social system. And this new social and political system is radically different than what the kingdom of Macedon, which was this kind of provincial, out-of-the-way, small Greek kingdom, was practicing. And they're not governing these states the way classical Greek civilization was oriented around city-states. No, these are a new type of entity. So I basically think that Alexander the Great had a genius around him, the genius of his scene.
Samo, one of the really interesting things about talking to you is that it feels like you've absorbed so many historical examples that you have the search algorithm where for any topic that's input, you can just pull historical examples out of your mind, which is pretty cool and a pretty interesting thing to do. And makes me think about a way of thinking about people's expertise as learn? What topics can they just pull examples immediately for whatever's being discussed?
I think that's it's an interesting test, but it's not sufficient. I think one has to check for all sorts of additional constraints when evaluating thinkers. But thank you for the compliment.
Anything you want to share with the audience before we wrap up?
I would strongly encourage people, if they want to understand and think about history in a way that's actually applicable, that's actually useful, to do very close case studies of either particular organizations or particular relatively narrow periods and try to analogize them with what you know about humanity. Like, the correct way to use history is sort of like, these are human beings like you. You are acquiring a new data point on what can be done. And one of the most fruitful uses is when people have a clear, narrow understanding of a particular historical event in enough detail that they can reconstruct the social technologies or tactics that exist in that time period, and then fruitfully apply it to the present. I think the historical record isn't just a warning for things like civilizational collapse and so on. It's also a source of hope. It's an existence proof, right? What one human being can do, another can do. And there are all sorts of things that I think today we've grown to be accustomed are impossible. I think we're a little bit like, the elephant, where we've learned that we are going to remain chained and there's no reason to go elsewhere. I think if that elephant, that chained elephant, sees a different elephant traveling freely, well, maybe that breaks him free from his delusion.
Samo, thanks so much for coming on.
Thank you for having me on the show.
Okay.
That is 2.5 hours. As much as I like Wolfram, we need a break. hell did he go? Oh, it just, I don't know. Oh, what was that? He goes running in that direction again. See, she knows what's up. Both of them. You know, assholes just running everywhere but here. Ooh, the cop came. Oh, there he is. No, wait, never mind. That's not the cop. That's just... I don't know. Okay. They found a way. I could have just hidden in the store. I'm silly.
Salutations, scumbags. Are you ready for another day of carnage and chaos? I know I am. For those of you who don't know me, I'm John Dick, your guide and confidant on this journey of mayhem. Get ready to get bloody. Welcome, friends, to Scum Island. The best way to gain fame and fortune is by registering for one of our events. What are you waiting for, scrub? Sign up and rank up. Let's play some tunes, shall we?
think I'm sexy?
Welcome to the Thunderdome, bitches. John Dick here, inviting you to join in on the fun as our prisoners disembowel each other for fame, prizes, and yes, the sheer joy of it. Our producers have lined up some amazing tournaments for you. Sign up and revel in the glory, or die like a worm. The choice is yours. Let's get some music on to set the mood.
Oh man, this place uses freaking cameras. Maybe I should just buy a camera lens next trip. Just fell down, but yeah. Okay.
But I can't stop my from flying away. Strange how
Oh really? That stopped it. Whatever.
and the time don't wanna leave my girl. Have to go. Why do you have to stay? Those are things I don't know how to say. Don't wanna leave my girl. Why do you have to?
Zombies are dead, but our cameras are play-by-play action to satiate your bloodlust. I'm John Dick, and welcome to Scum Island. Once you're ready, be sure to sign up for one of our mini events. Challenge yourself against other prisoners. Team up and overcome for blood and glory. And don't forget, the bears are more afraid of you than you are of them.
can't break out. You meanie. But they can't break in though. Maybe I should make a gate for them or something. That's a searchable object. I don't know, maybe I could. Anyhow. Let's see, I want cornflakes, that's what I wanted.
Kill or be killed. That's how it works here on Scum Island. My name is John Dick, and I'd like to invite you to join us as our prisoners mutilate each other for fun and prizes. We've got some interesting events for you to check out. Try your hand at deathmatch, team deathmatch, capture the flag, or cargo drop. And don't forget, the bears are more afraid of you than you are of them.
There was a hazy day downtown L.A. when I met her on an elevator on its way up to the hotel room of my fiancée. But I never made it there 'cause she come tearing through my life like a tornado, coming on hotter than a big potato. She spin me around and see you later. Wanna hate her, but I love her instead. We caught the red eye to Dubai. She was blowing through my door like it's going out of style. In general, I'm a sensible guy, but that guy died when she come tearing through my life like a tornado, coming on hotter than a big potato. She spin me around and see you later. Wanna hate her, but I love her instead. Go. Well, I lost my job and all of my money, most of my friends and half of my mind. So messed up, it's a little funny. And I thought for sure that she was mine. But now I'm alone, trying to get right, picking up the pieces of my busted life. If she walked into this room tonight, I'd say, baby, won't you come tearing through my life like a tornado, coming on hotter than a big potato. She spin me around and
okay idea.
Yeah, murder is fun, but if you tried Indian food, shit's amazing. I'm John Dick, and today's match is brought to you by Pong's House of Curry. So good, it'll make your asshole bleed for weeks. The best way to gain fame and fortune is by registering to one of the games. What are you waiting for, scrub? Sign up and rank up. Let's play some tunes, shall we?
questions. You ain't giving this a chance to burn its light. 'Cause I'm coming up strong. Grass should've looked greener. I need a true believer in disguise. If I'm loving you wrong, short changing and receiving. Girl, you best be leaving me behind. 'Cause I'm over easy. I'm over easy. And I'm over easy tonight.
I guess it's just that wall that's being weird. Eating up all my materials.
Lifting slowly from my bed, I shake my head. I've done this before. So tell me, darling, once again what you said and what you swore. 'Cause the sight line goes over the tree line. Lord, it's so much easier.
Why are the models different?
You know that you got nothing to fear.
Just a... Oh. It's a different... Oh, okay.
Never see it because you're nowhere near. While the bomb drops all the way across the sea. All
Okay, whatever.
the way to me. Well, I chose this life, now it's choosing me. And how it interferes with the lives we lead. And I can't read your eyes, they're just sending hollow lies for free. And my left brain, it tells me never again, there's nothing left. There's nothing left. Well, just go home now. Your skin and bones, but there's no way of hiding your theft. You're successful in sending your problems from your stream. The way to me.
I feel like I... Wait a minute, yeah, I did. Too much. I'm silly.
get loose for the cat trick, then it was silly. Anyone came and mourned when he tried to make me pay the rent. Said I ain't got no money for you, can I pay him away with these dancing shoes? Thought I was kidding. Father, Father, what you owe me, I can't count on anymore. Till the police come and knocking on our door. We'll be burning down the house, tear it to the ground, burn it up, tear it down, burning down the house. Well, I spent some time in a backwoods town, the Duke saying nothing around. That sheriff ran around the block, streets empty and the doors are locked. Got pretty lonely. When that priest there came ring my bell, tell me a little about heaven and a lot about hell. I ain't got no money for you, can I pay away with these dancing shoes? I thought I was kidding. I was not kidding. Father, Father, what you owe me, I can't count on anymore. Till the angels come and knocking on our door. We'll be burning down the house, tear it to the ground, burn it up, tear it down, burning down the house. The world outside is mad and cold. You don't grow up, you just grow old. Soon it's over, so they say. God Almighty, till that day. We'll be burning down the house, tear it to the ground, burn it up, tear it down, burning down the house. Burning down the house, tear it to the ground, burn it up, tear it down, burning down the house.
a singular feather is blocking my progress.
They call me the juggler, 'cause I always have three lovers, and I burn through Trojan rubber like no other. But when I'm not between the sheets, I'm busy staying undercover. Ain't as sweet as it seems being the juggler. Yeah, 'cause Edith likes eating at East of Eden, where Wendy works on Wednesday evenings, and Donna Lee does her laundry 2 doors down. So when I'm out to eat with Edith, I'm always worried Wendy's watching, and equally that Donna Lee's gonna be around. And what's worse is Wendy lives by the one-eight world, where Donna Lee goes to the pharmacy, and Edith's ex-old man's employed there. So I choose to keep a low profile and sneak around like it's going out of style, and try to keep these balls up in the air. Yeah, they call me the juggler, 'cause I always have three lovers. Sometimes I wish I had me a twin brother, because it takes a lot of steam making all that hubba hubba. Ain't as sweet as it seems being the juggler. Yeah, but I had three more the month before, Tanya, Tina, and Isadora, but that all ended in a puddle of tears and blood. I had Tanya down for 10 to noon, and Tina turned up around 1 or 2, and Izzy used me all night like a stud. But one day Tanya showed up a little late, and Tina turned up a lot early, so fists were flying till Izzy came that night. I'm pretty sure it's the doors when they threw me on the floor, while Tanya and Tina punched and kicked and swore, and long story short, I lost the fight. Yeah, they call me the juggler, 'cause I always have three lovers. They come and go, but there's always another. Yeah, I guess I can't be pleased by just one lady's company. Ain't as sweet as it seems being the juggler. Yeah, maybe someday I'll quit this fooling round, find someone to make me settle down, but I'd hate to be the one to make her suffer. 'Cause one of them days we'd go to town, and one of my friends would flag us down and say, "You know why everybody calls him the juggler?" And I'd have to explain that they call me the juggler, 'cause I always have three lovers, and I burn through Trojan rubber like no other. But when I'm not between the sheets, I'm busy staying undercover. Ain't as sweet as it seems being the juggler.
Tempted to use a tree. I'm gonna use a tree branch to see how if it's a monumental waste. It is a monumental waste indeed. fighting it even with this wind. Lost track of wherever he went. I drink out of everything but the water bottle I keep on me for the sole purpose of hydration. Anyways, it's time for that intermission. So I'll BRB. Okay, well, we're doing it to it, I guess. We got, all about 2 hours left to go. I mean, and it's daytime, so we're not gonna listen to Wolfram as much as I want to know what he's gonna, be saying. But it's neither here nor there. We're doing just fine. See, Ray's hosting me now. Not that much longer to go, but it's always appreciated. Here we go. And we're just working on stuff. I even forgot what we were working on. Oh yeah, there's a bed in there. You gotta, I don't know, see about that fucking blueprint there. Maybe I turn on God mode at the end of this and see if I can, redo that or something, because that's fucking weird. We can go find a feather in town real quick, I guess. Didn't find a camera lens. Our hunter is low. Only 3 bullets. 3 bullets to waste, because, we were trying to waste all our crappy ammunition. Who knows, maybe there'll be a stray feather in the junk heap. There's definitely one in a coop. There's pretty much always one in a coop. But maybe I won't even have to make the journey. But probably will. And watch, there are going to be like a million puppets now just swarming the space, I guess. Since I decided to go on foot and just take a brisk jog into town. I think I checked all these already, right? Maybe that was earlier. Yeah, no, I already checked them. Okay. Just on the quest to get a feather. A single feather for our bed. I guess I should cut some long wooden sticks too. Since I wasted a whole freaking tree branch to fill one slot in the bed. But it's alright. It's alright, we expect these things in early access. There's our singular feather. Can we get a twofer camera lens somewhere in here while we're here?
These days, you are young, you best be on your way. If you wanna be a fiddler someday, you better get to practicing before you're old and gray, and your best years slip away.
odd that there are no puppets. Not that I'm complaining, but it's a far cry from earlier when we were just freaking swarmed with them. I suppose it's feast or famine with these server settings. Then again, maybe it has to do with the cooldown times on them, because yeah, maybe that is it. If we drive through, spawn them, and then drive so far away we despawn them, and then come back within the 1800 seconds or whatever it was, they just can't spawn again. I'll have to change that, I guess, which, might mean that, hordes are continuously spawning, seemingly coming from nowhere, but and there's no breathing room, but that's kind of the joy of the experience, right? Making the environment an actual threat in these games. He has his earplug. Yeah, earplugs plugged in behind his ear. Well, that one's right, but this one's wrong. Yeah, whatever. I'm silly. I forgot where I was going. Wooden sticks, so we need wooden boards and ranks. Okay. I just swear I heard something. Just imagining things. I don't really know what I changed that would lead to me heating up like this. I guess it's just extremely hot midday. It's a scorcher out. Really not a single puppet I can waste this bullet on. Boring. Oh, that's why I shouldn't have used all those bolts. Okay. Gonna be a while before I can make an improvised workbench. Not that I know where to put it yet. Alright, I got the plan. I know the plan. It's in my head as a plan. Just one of these things is not like the other. Alright? Yeah, there it is. Cut down the tree.
Take this hurt, lady, throw it in my face. Don't let these bones slow down. 'Cause I'm coming on strong. Grass should have looked greener. I need a true believer in the sky. Yeah, I'm loving you wrong. Short changing and receiving. Girl, you best believe in me behind. 'Cause I'm over easy tonight. State the truth, spit it out, I'm waiting. Don't leave me contemplating my own life. Same bullshit for another man or lover. Don't need a 40 clover to decide. 'Cause I'm coming on strong. The grass should've looked greener. I need a true believer in disguise. Yeah, I'm loving you wrong. Short changing and receiving. Girl, you best believe in me behind. 'Cause I'm over easy tonight. Oh, hey. Oh, hey. Oh, hey. Yeah, 'cause I'm over easy tonight. Who wants a lady without the thrill of chasing, like taking cotton candy from a child? Too many answers, but all we need is questions. You ain't giving this a chance to burn its light. 'Cause I'm coming up strong. Grass should've looked greener. I need a true believer in disguise. If I'm loving you wrong, short changing and receiving. Girl, you best believe in me behind. 'Cause I'm over easy. I'm over easy. And I'm over
do have a feeling like this whole thing should be fenced off. You know, kind of hard. Yeah, because it needs enough room to fit a plane. It's coming in for landing. Can't have it highly segmented. Kind of needs to be wide open, but I don't know, still fortified. We'll see, we'll see. pretty sure that was a puppet sound. That was some sort of sound, maybe an animal. Who knows? I'm investigating though. Guess it was nothing.
Told me that now we've reached the end, neath that setting sun. I hate you so much, I stole your bicycle. It's all said and done, now honey, you won. Gonna leave for a while, walk out the door. Forget my troubles and move to Memphis, maybe change my name. And since you left me right at your door, I'll never be the same.
Yeah, murder is fun, but if you tried Indian food, the shit's amazing. I'm John Dick, and today's match is brought to you by Pong's House of Curry. So good, it'll make your asshole bleed for weeks. We've got some interesting events for you to check out. Try your hand at deathmatch, team deathmatch, capture the flag, or cargo drop. Let's play some tunes, shall we?
I mean, we were just sitting back, you know, chatting it up, reminiscing about the my roots, where I came from, where I'm going.
It's starting to lag out when I do melee. That's the sign of memory issues. It's starting to take up too much memory. But we got like an hour to go. We'll be fine.
Ain't nothing changed with the weather. The dangling carrot in hand from the river. The dreams in the past. Backseat driver. Sugarcoat the rhyme sometimes, but still say it. Said I was quitting at 40 is just a fib. I'm still a kid that's wiping the food off of my bib. You ever wanted something so bad that you could taste it? Cried over every opportunity wasted. Good and bad news, which one you want first? Either way you pick, the bad still gon' hurt you the worst. I never got to bask in the fruits of the labor, and I never got the cash from that dude from the label. I'm just thinking back. Can we go way back? I would've did it the same. In hindsight, I'm the only one to blame. I ain't picky, I'm just real specific. I want nothing less than terrific. I know y'all get it. I'm aggressive, so our style is clashing. Killer instinct, and I play with passion. For being one of the love for these overrated appearances. I can stand on skill alone, but I'm a package deal. I can write the whole song and rap for real. I got my head in the cloud with a pun intended. I don't need to see nobody, I don't want no visits. Introverted, I just flirt with the music. Small circles, how I choose it. Stay away from squares, they the one that look like a L7. I've been doing this since I was 11, and the shit gets real. Remind me of my first show I did at the Red Sea. I ain't had no DJ, just the tape deck. Opened up a Son of Star Child, I love that. Met this cat named Larry, he was with the Avengers. Showed me how to make moves and walk with the winners. Soon went to the pen, I never seen him again. But I did a couple shows with his friends. Lumberjack, brown clown, so-and-so, and dude with the orange pants. 10 years later, now I'm rocking the orange pants. But they jabos though, you know, fresh to death. Always and forever. Don't get it twisted. Number one listed. Nitro with the nice flow. You know.
Might be getting ready to rain. Doesn't hurt to spend time inside, now does it? Like, how do these guys overlook a bathroom? Honestly, running an airfield, not even an outhouse. What's with you guys? Gonna just use this place. Why not? This rock pile. It's the poop rock pile. Can I just poop apples all the time? It's like, it's the same type of apple, too. Oh well. Obviously we're gonna eat the poop apple. Why not? You gotta eat the poop apple.
Welcome to Scum Island, where survival is the name of the game. Mass murdering maniacs eviscerate each other for fame and fortune. I'm your tour guide on this journey down a river of blood, John Dick. Let's do this thing. Our producers have lined up some amazing tournaments for you. Sign up and revel in the glory, or die like a...
It's clear skies. A bit late on that rain. Asshole.
Make your mama proud.
Keep the funk in their music.
Oh, now it's all gloomy.
So please, please, please don't walk away. Right now, I need you more than ever before.
Kill or be killed. That's how it works here on Scum Island. My name is John Dick, and I'd like to invite you to join us as our prisoners mutilate each other for fun and prizes. If you're tired of withering in obscurity, you can register for one of our glorious events. Gain fame and prestige, or die trying. Or both. Keep your head out there, players, and try to collect a few extra heads along the way. Here's some kick-ass music to start your day.
Do you think it's meant to be? 'Cause I feel like letting go. Can I spend some energy? My battery's pretty low. Do you see with clarity? Gotta tell you I know. What a possibility. I'm a listen close.
Should we? What would I need to upgrade it with? Takes quite a bit. Cancel that upgrade. You don't need that kind of negativity. About to level up driving. Sweet. We got another XP point in running. It's neat. Can go out and get scraps and stuff. Need plenty of metal to just do shit around here. Oh yeah, I'm gonna need plenty of bolts for the workshop. Can't use so many. I'm not sure. That looks like something in the distance. I think it's just a watchtower. Yeah, it's a watchtower. I don't want to risk, going offline in a, or ending the stream in the what's it called out outpost, just in case they decide to blow up my car or something while I'm offline. Who knows? Maybe. Okay, maybe we make a trip. Somewhere. Thing is, there's not really anything. Well, that's not true. There is another city along the coast if we keep going, and I think that loops back into the outpost. So I think that'll be our mission. We'll make that our mission. Meanwhile, I have nothing in the hunter. Let's actually put stuff in the hunter and then switch to our shotgun for our long gun. Actually, no, we need to get back to our crossbow. So that. And I should have collected more feathers so that we could make more bolts for our crossbow. Our fun little crossbow. For I am silly. Hear me roar. Oh, what the heck? Oh, what the heck? Heck the what?
You know, when you're not mine, you're all I'm thinking of. Mystery just like an open road. But you came to me with your arms open wide. Now I can love you anymore. 2, 3, 4, long summer night. And it'll be the cry. All the tears I cannot hold inside anymore. I feel like going away to somewhere peaceful, somewhere where the river's high and strong. Diving in so deep, so I could die in peace. No one will see me anymore. 2, 3, 4, long summer night, and it'll be the cry. All the tears I cannot hold inside anymore. I said all the tears I cannot hold inside anymore. All right.
John Dick here, thanking you for joining us for another glorious battle. The best way to gain fame and fortune is by registering for one of our events. What are you waiting for, scrubs? Sign up and rank up. Let's get some music on to set the mood.
And I said, what would you do if you could all your burdens? Yeah. And I said, my words are few, but I love you. Those words, please hear them. Yeah.
Okay, this is actually a battleground of some sort. I'm in Alpha Team space. Had that one covered. Okay. It was in the wardrobe, not the cover. Same principle. Yeah. Spent a lot of time in this place, not even the town proper. How can you expect to find your camera lens in a dinky little manor? Is it a manor? I don't know. It's separated from the main town. It's where the Lord lives. I don't know. Either way. We gotta go to the main place, see if we can get camera lens. Definitely a lot of cars to get metal scrap from. I think you can find the camera lenses in empty cars, in broken down cars, car shells, car husks. Wonder where Bravo team is. That's the question of the century. don't know where this asshole is. Yeah, I'm guessing he's in that room. I just spooked him. Poor baby. Hey, how you doing? Really, just went through him? Yeah, hold on, mate. I'm gonna just give me my bolt back. Don't worry, I'll be right with you, mate. You're right with you, mate. There you go. Asshole. I don't know how much daylight we have. Wait a minute, I can figure this out. I have a check time action if I fucking paste on this. Okay. Alright. Take two. 19, 12, almost 20. Oh, it's almost. Well, it's 20 minutes to nighttime, right? Oh, yeah, sun's already setting. Why do I always do this? Pisha. It's just. Frick. Never got the useful junk that I want. Just one camera lens, that's all I ask. That's all I've ever asked. In life, in death. Let's find the police station and then, I don't know, be on our way. What's this? That's what I thought. No one threw away a camera in church, come on now. Kind of in speed mode, right? Speed looting mode. It's not really speed loot. Not a speed run. Thought there was gonna be be so much more daylight. But alas, it was not to be. Lots of cars. Just can't believe the lack of camera lenses these past few days. By a few days, I mean like 2 days. Haven't really been looking for them for that long. I think I'll just buy it though. Bought the drill, why not? Alright. Well, that is what we've got for today. It's like what? Only 14 minutes left in the stream. Data's going down, don't want to log out. In and out post. So we'll tomorrow go back down through the police station, go through the outposts. Get back home, and if that wall is still blue, I think we're gonna have to destroy it and then just God mode fill it, because we filled everything in already, which will disable achievements, but then we can just restart the server. Anyhow, and that's what it looks like for us. I can do this now, can't I? I can just say, quit me. I don't know, it's proof of quit, and then just go to that screen. But anyhow, it doesn't make much difference. But, and anyways, neither here nor there. We had fun. We did a lot of building. Things are shaping up. I think I'm having a better conception of what I want to do with that whole airfield, how the base will look finalized, but still a long project, still a big project. However, I will see you guys